All right, we might get started. Welcome everyone to day two. We'll be taking you for methods. My name's Ethan. We've got An and Hugh as well, and Asia as well. So first, we'd just like to acknowledge the traditional custodians of the land we're gathered on today. I pay my respects to the elders past and present, for they hold the memories, the traditions, the culture and hope of Aboriginal and Torres Strait Islander peoples across the nation. So just an intro to me. My name's Ethan. I'm the lead tutor for today. I play guitar and bass in a band with some mates. I love camping and hiking in the outdoors. And I took the biology seminars for the past 2 years, but I'm not doing it this year. Let me know if you came to bio last year. We'd love to see if anyone was there. These are just some photos of me. This is me and my friends camping near Mount Hotham. This is when we made the very bad decision of trying to take some pool toys down a whitewater rafting river. This is when we decided that we had almost died a few too many times and we started walking back. And this is me in Thailand.
Hello. My name is An. So right now I'm currently studying computer science at RMIT, since technology is my main passion and all. Also, I love gaming and anime. And yeah, that's about it. You can see me right there, enjoying my food.
And good morning, everyone. Thank you for having me. My name's Hugh. I am a director at UBS, which is an investment bank. I studied math methods some time ago, back in 2007, but it's a subject I really enjoyed doing. So really glad to be here, and please ask me any questions. In terms of sort of hobbies I like doing outside of work, as I say here, enjoy watching Formula One, playing golf and bike riding. So you can probably tell my hobbies a little bit older versus everyone else.
Awesome. All right, so just like a disclaimer with some Zoom etiquette. So we're in Zoom webinar mode today. So we won't be able to see any of your faces, but you can use the Zoom chat. So if there's any tech issues, you can be like, Ethan, you forgot to share screen or something like that. And I'll also be asking you guys questions. So I'll be like, what is the answer to this or something like that. There'll be 8 pop quizzes and they're completely unrelated to maths. So it's just like a little bit of a break, a little bit of fun. We can use Mentimeter for Q&A questions and pop quizzes. So there'll be some Q&A sections for today, and also the pop quizzes, you can answer on those. And there's also some multi-choice questions that we can answer on the Mentimeter. And in the event that there's any problem with Zoom, you can use the original link to get back to this webinar. But you can also, if it doesn't work, we'll be sending out an update via email. So if everyone can jump onto Menti now, so type in menti.com and then use that code 79146739. And our first question is, how are we feeling about the methods exam?
Yeah, so if you guys can quickly go to menti.com and then just put in the code. I'll post it in the chat again just to make sure.
Cool. So still got some people filtering in, but we've got a lot of, we've got 2.6 out of 5. So it's all right. Most people are feeling a lot worse about methods at the start of like the end bit of the year. So 2.7 is not too bad. And there's a lot you can do in a few months. So hopefully we'll be bumping that up to maybe 3 or 4 today. All right. So this is the agenda for today. So we've got the morning session and the afternoon session with lunch in between. So lunch is from 1 to 2. That's the most special part of the day, of course. So we've got an introductions and agenda, We've got area study 1, so that's functions and graphs. So we take a quick break. Area study 2, that's algebra, do some practice questions, take another break. And during that break, we'll be doing a bit of a Q&A. Then we'll be doing differential calculus and break, and then integral calculus and some practice questions, then lunch. And then we'll come back for some probability. So discrete and binomial probability, take a break, and then continuous and normal probability. And then we wrap up and do a quick Q&A. So it's a long haul today, everyone. Hopefully we've got enough breaks to clear the mind. And hopefully we don't burn out by the end of it. So the basic outline for each area of study, we'll do some content, we'll do some practice questions, then we'll take a break, and then we'll repeat. And I'll be asking questions, so please have a go at answering them in the chat. The more you answer, the more you'll get out of it. And yeah, so first pop quiz for today. Which VCE subject is the best VCE subject? There is only one correct answer for this, by the way. E, none. I love that. All right, let's see how you went. Good, so most people got it correct, which is methods. Biology was a close second, but I actually do think methods is the best subject. All right, cool. So the way I look at methods is that we are mechanics and we're trying to fix a car. First thing you want to know is, what do we want to fix about the car? We're trying to fix its engine, trying to fix its tires. What are we doing? And that's what we want. So that's what we want to do. The next thing we want to know is, what do we have? What information do we have about the car? Is it a Toyota? Is it a Holden? What year is it from? Etc. That's what we have, the information that we have. And then what we want to do is, using that, what we want and what we have, we figure out how we get from what we have to what we want. So we pick a tool from our toolbox to fix the problem. And if all else fails and you have absolutely no idea what to do, just open up the car and try things till it works. So what we figure out what we want, we figure out what we have, then we figure out how to get there. Okay. Tip number 2, learning methods is an active process. You have to set your own practice questions to set yourself up for success. And that's the only way to become really proficient and really get to know the tools that you have in methods. So if Anne could just send that link on the chat. This is a link to a Weebly website that I found that has like thousands of worksheets and it's ordered in the topics. And I've been giving that to all my students. That's really useful to practice specific areas. We won't be covering everything today. Even though we are here for a very long time, it's still not enough to cover the entire year, but we'll be covering all the important things. Another tip, if you don't understand how a question was done, read the notes for that topic again. So that could be your own notes, that could be from the textbook. Find a similar example in the textbook or from your teacher's notes. Watch some online videos, ask people around you, ask your teacher, and then write the notes. Once you understand it, write the notes in your summary book, and then do some more practice questions in your summary book. And I'll reiterate this a lot today, but the summary book is the most important thing, because that's like your substitute brain if you forget anything. And it's okay to not know, it's okay to have absolutely no idea what you're doing. Most people have no idea what they're doing in methods at this point of the year, but people do a lot of learning from now until the exam. And the only way to do that learning is to make mistakes. So the biggest mistake you can make is to not make a mistake, if that makes sense. So give it a shot. That's the only way you'll be able to learn how to do the question better next time. Okay, redo questions and do them again. I always tell this to my students. If you get a question wrong, redo it. And then if you get it right, don't just stop there. leave it for 2 days from then and do it again, because there's no point in doing it right the second time immediately after and then forgetting how you did it a few days hence. So redo them again. That's really important. And now if everyone could, I'll just give everyone a minute to get a book and a pen, because we'll be doing some practice throughout the presentation. So I'll just give you a minute for that. If we could just say in the chat, ready to go when you've got your materials. Cool, got some people ready. All right. Let's have a go at this. So this isn't like a question. This is more of a, well, you'll see. So what is wrong here? So this student has read the question, find the coordinates of the intersection of the following graphs. So you've got this parabola here, and this linear graph here. And they've made them equal to each other. They've solved for X, and they've left it there. Can you type in the chat, what is wrong here? So this person maybe might get 1 mark, but they wouldn't get the full marks. Why is that? Good. Yes, good. So they found the X coordinates, but they didn't find the Y coordinates. That's really good. So the most important thing when you're looking at these questions, remember it was the what you want, what you have, and then how you get there. So what we want is the coordinates. So we have to really read the question and highlight. We're wanting coordinates, means the co meaning 2. So you have to find the Y values. All right. So in terms of the structure of the methods exam, we've got tech free, which is 1 hour, and tech active, which is 2 hours. Just because we're running a little bit behind time, I was going to say how many minutes per mark. Does anyone know off the top of their head? It's 90 seconds per mark. So 1.5 minutes. All right, cool. So first area of study, graphs. Can anyone tell me what type of graph that this first one is? Linear graph, well done. You guys are smashing it already. It's a linear graph. What does the M tell us about this graph? So this is how I go through graphs when I'm trying to learn these things. Different parts of the graph will tell you different things. Good, so the M tells you the gradients. What does the C tell you about the graph? Y-intercept, you guys are amazing, all right. And then once we draw the graph, it'll look something like that. Cool. What type of graph is the second one? Quadratic. All right. What does the A tell you about the quadratic? Good, dilation. Can also tell you something else. Good, reflection, yes. So I like to call it the direction of the graph. So is it going up or down, positive or negative? And it can also tell you the dilation, but it doesn't always tell you the dilation. So in this first form, it doesn't tell you the dilation exactly, but it can tell you the direction. Because it needs to be multiplied to the entire function for it to tell you the dilation. What does the C tell you in this form? Y-intercept. Awesome. Good. This is known as general form. So this is like a really good way of setting it out in your notes. Just say, what kind of form is it? What do those different parts tell you about the graph? This is known as turning point form. Can anyone tell us what special feature we'll get from turning point form? Good. Yeah, awesome. Turning point, good. So sometimes it is just on the name of the can. It does what it says on the can. It tells you the turning point, and the turning point will be at h, comma, k. Now note we have x minus h here, but we have a positive h here. So the minus h actually means that it's a positive. So we'll discuss that a bit later, but sometimes it's the opposite when we're talking about x values. And this next form is called x-intercept form. Can anyone tell us what's the what interesting features we'll get from that? X-intercepts, well done. Cool. All right, not too bad so far. And the quadratic will look something like that. And that's a positive quadratic. And then the negative quadratic will look like that. All right, what type of graph is this third one? Cubic, well done. What will the A tell you? It's kind of similar to the quadratic. Direction, perfect. And not the C this time, but the D. What does the D tell you? Y-intercept, well done. You guys are so smart. All right, what type of form is this one? Point of inflection, good. So it's not exactly a turning point because for cubics, it doesn't turn around at this point of inflection. Good. And the point of inflection will be h, comma, k. So it'll look like this. The turning point on a quadratic would look like that because it actually turns around, does a U-turn. And this last form is x-intercept form. And just like quadratics, it'll give you the x-intercepts. So we'll draw a cubic like that. That's a positive cubic. And a negative cubic will look like that. Perfect. All right. Okay, so basic structure of how to graph things. I like to split it into steps so you remember everything from it. So what type of graph are we dealing with and what form, if that's applicable? What direction is it going in? What are the intercepts? So x and y intercepts. And then what are the interesting features? So if we were to go through this one really quick, just discuss it. This would be a quadratic. It's currently in general form. It's in a positive direction because the a value is 1. The x-intercepts would let y equal 0. For the y-intercept, we let x equal 0. And interesting features, for quadratics, the interesting features are turning points. But there are other interesting features for different types of graphs. All right. So I'll give you guys a couple of seconds to try and graph this graph. Not too hard to begin with. And you can use these steps and then we'll go through it. All right. You may not have gotten all the way through it, but we'll give it a shot. Just in the interest of time. So can everyone tell me what type of graph this is? Quadratic, easy. What form is it in? I think we already discussed it, didn't we? General, excellent. What direction? Positive, good. Okay, let's go to the intercepts. Let's find the x-intercepts first. So we need to let y equal 0. So 0 equals x squared plus 2x plus 1. And we know from our quadratic factorization that this is x plus 1 squared. And then we use null factor law, and we get x equals -1. Okay, that is our x-intercept, there's only one. Now for the y-intercept, we let x equals 0, y equals 0 squared plus 2 times 0 plus 1, y equals 1. So our y-intercept is at 1. Now, if we want to make these coordinates, we say -1, 0 and 0, 1. Interesting features, so that would be the turning point for this one. One good tip for getting the turning point of a quadratic, this only works for quadratics, is to say the turning point is that x equals -b onto a. And this is when we consider it in the form ax squared plus bx plus c. So it's only in general form. And so b is 2, so -2 on 2, and a is 1. So -2 on 2 times 1 equals -1. So our x value of the turning point is -1. And since we know that that's an x-intercept, we know that the y value is 0. And then we could just join in the dots. Cool. And hopefully your drawing will be a bit better than mine. All right, how are we feeling with quadratics, graphing quadratics? Good or bad? Pretty good? Okay. Awesome. All right, let's move on to something a little bit harder. So now we're talking about trig. First graph is a sine graph. We know that the sine graph starts in the middle and it goes up and then goes middle, then it goes down, then it comes back to the middle, and it could keep going like that. The a value, what does that tell us? Amplitude, good. And it can also tell us the direction, very good. So it tells us two things, the amplitude and the direction. Now, we have to remember that the amplitude is always going to be written as positive. Even if it was -3, the amplitude is 3 and the direction is negative. What can the b help us find? Period. B can help us find the period. So b does not equal the period, but it helps us find the period. So period equals 2 pi over b. Cool. What does h tell us? X translation, good. In other words, horizontal translation. And k? Vertical translation, or the center line, good. Central line. So vertical translation, or the central line. All right. Now, for anyone who's getting confused by all this gibberish, it'll make a lot more sense once we put numbers in. Letters always look more confusing when in maths. Don't worry. For cos, it's exactly the same, except it starts at the top, goes to the middle, goes to the bottom, goes to the middle, and then goes back to the top. That's the only difference. All right, next question. Let's try and do this graph together. What is the a value? And also, what does it tell us? Good, a is 1. So that means the amplitude is good. So amplitude is 1 and the direction is positive. Good. How can we get the period? Two pi over 2. Well done. Pi. Awesome. What does the 1 tell us? Translation 1 unit up. Good. Or the central line. All right. So k equals 1. So this is what we write important features. So we would have gone through all the steps. So what type of graph is it? It's a sine graph. What direction is it in? What are the intercepts? So we're not going to worry too much about the intercepts for this one. And interesting features, this is what we've gone through here. So we'll draw in our central line. So you can draw it in like that. And then we know it goes 1 unit up to 2 and 1 unit down to 0. And that's because the amplitude is 1. Then what we do is we just decide, okay, for this one, we're just going to draw it for 1 cycle or 1 period. So we'll go from the start, which is 0, 1 period to the right, which is pi. Okay. In the exam, they'll tell you how many cycles to do it or for what domain to do it. Then we decide, okay, this is a sine. That means it starts in the middle, not the top. And then what I like to do is I like to split that 1 cycle into quarters. So halfway between 0 and pi is pi on 2. Halfway between 0 and pi on 2 is pi on 4. And then halfway between pi on 2 and pi is 3 pi on 4. Okay, so now we've split it into quarters, we can put in a few dots, okay? Now remember how I said sine goes middle, top, middle, bottom, middle. So we can put in dots like that, and that'll make our graphing so much easier. So you start in the middle, we go to the top, which is that 2. Then we go to the middle. Then we go to the bottom. Then we go to the middle. And now we just join the dots. Oh, sorry, the symbol in front of 2 pi on 2 is p, but I am terrible at writing. Cool. Does that make sense to everyone? Yep. Good to hear. All right, I think we'll skip that just in the interest of time. Can everyone have a go at this? So you'll get 90 seconds and it'll be on Mentimeter. Cool, we got some answers filtering in. All right. Got 48 answers. 49. Cool. So the answer was C. Well done, everyone. The way that I would do this is exam 2, so technically you can use your calculator, but I've found that once you get good at graphing trig, it's actually easier to just do it by hand real quick, and then rather than typing it all into your calculator. So we know that this -1 tells us the central line, -1. We know it's going to go up by 5, so it'll go up to 4 and down to -6. And then from there, we know that the period, we'll get the period from the b value. So period equals 2 pi on 2 equals pi. And then we can just graph it real quick like that. And even though the graph looks terrible, we can still glean from that the period is -6 to 4. I mean, the range is -6 to 4, and the period is pi. Cool. Well done, everyone. All right, time for a pop quiz. Name this album. This is essential knowledge for your methods exam, of course. Remember to type your answers in Menti so no one else can see it. I love that people are putting their answers in so much faster for this because it's such essential knowledge. Oh, yes, I knew there would be a split between A and D, but it's actually Good Kid, Mad City. El Camino by the Black Keys also has a picture of a van as the album cover, but it is Good Kid, Mad City. Well done. Transformations. So with transformation, this is one of the most complicated parts of the method study design. But once you get it, you get it. So the plus k at the end, if we add some number at the end of our function, this is going to translate it in the y-axis. In other words, it's going to translate it vertically. So we can see here that we've got y equals x squared, and then we've added 2 to the end of it. Now that's different to adding it just to the x, and we'll talk about that later. So adding 2 to the end of it will translate it 2 units in the positive direction of the y-axis. Horizontal translation. So this is when we translate it directly affecting the x. So it's inside the bracket that the x is in. So if we say x minus h, this is actually a positive translation in the x-axis. So that's the opposite of what you'd think. You'd think x minus 2 would make it go to the left, but it actually goes to the right. So we see y equals x squared, y equals x minus 2 bracket squared. That'll move it to the right. Y equals x plus 1 squared. That'll move it 1 unit to the left. Dilation from the x-axis. So make sure you write from, not in. In the x-axis means it's going in the same direction as the x-axis. From the x-axis means it's being stretched away from the x-axis. So actually in the y-axis. The way that we dilate from the x-axis is we times a number to the entire function. So for example, a times f of x. That's a dilation of a from the x-axis. So y equals x squared times the entire thing by 2. See, this point goes from 1, 1 to 1, 2. So everything gets stretched upwards away from the x-axis. Or we can squeeze it as well. So half x squared, the y value of 1 becomes a half, and you're squeezing it down towards the x-axis. But it's all in relation to the x-axis. Dilation from the y-axis. So this one trips people up a lot. But a dilation of b from the y-axis is when we have x over b. So think of your x's are usually the opposite of what you think. So x over b is a dilation of b from the y-axis, not a dilation of 1 over b. Okay. So we start with y equals x squared. Y equals x on 2 squared is a dilation of 2 from the y-axis, not a dilation of half. So it's the opposite. And a dilation, and y equals 2x all squared, that's a dilation of half from the x-axis, from the y-axis, sorry. Okay. We'll just give you a few seconds to soak that in. Does everyone feel kind of okay with those transformations? Yo, cool. All right. So when is x, we'll go to this slide. When is x weird and when is it normal? So by that, I mean, when does -2 actually mean to the left? When does -2 actually mean to the right? So it depends what form the graph is in. When it's in a formula, so that means it has a y value and an x value. Let me just write that in. When it has a y value and an x value, then it's weird. So that means a translation of 2 to the right. When it's in coordinate form, so it's got these coordinate brackets, that means it's normal. So that means also a translation of 2 to the right. When it's in matrix form, so it's got these matrices brackets, that's also normal. So 2 to the right. So the only time that the x is weird is when it's in the formula. So that's when it's going the opposite direction to what you think. Okay. Let's have a go at this question. We'll give you 2 minutes for this. Oop, don't tell everyone the answer. It's okay. Oh, sorry. I saw a message where it was only said on hosts and panelists. My bad. That's all good. All right. Let's have a go. So following sequence of transformations is applied to the graph of the function this, translation of one unit. So the first thing I do whenever I see a domain is highlight it. Doesn't matter if it's gonna even be relevant to the question. I always highlight the domain because VCA likes to trip people up by putting in a domain. So there's a translation of one unit in the negative direction of the x, one unit in the negative direction of y, and a dilation from the x-axis of factor 1/3. The rule of the image of G after the sequence of transformations has been applied is, so take it one step at a time. Our original function is g of x equals f of x plus 1. Oops, sorry. F of x plus 1. Translation of one unit in the negative direction of the x-axis. So we're going to name this new function g1 of x. So that's going to be one unit in the negative direction of the x-axis. We'll get f of x plus 1. And then translation of one unit in the negative direction of the y-axis. F of x plus 1 minus 1. And then a dilation from the x-axis of factor 1/3. So this might be where some people struggle a little bit. We times the 1/3 to the entire thing like this. Because the dilation is after the translations, we times the entire thing, not just the f of x part of it. Okay, cool. Why is it -1? Oh, sorry, I forgot to put that in. No, that's my bad. Yep, and then those cancel out and you're left with that. Good. Well done. Thank you for picking that up. Good. So we had a question. I thought we had to do the dilations first. Okay, so you're thinking DRT. That is when you're describing transformations. But if the question gives you the transformations in a specific order, you have to do that in the order that they give you. If they gave it to you as 3 f of x minus 1, and they asked you to go from f of x to this, then you'd describe the dilations first, and then the reflections, and then the translations. But if they're telling you how to translate it in a specific order, then you do it in the order that they tell you. Cool. All right. Pop quiz. Who are these young lads? Okay, everyone should get this right, or I'll be very disappointed. The Beatles, well done. Well done, everyone. The Rolling Stones were their like arch nemesis. But yes, it is the Beatles. Good. All right, quick break. 5-minute break. We'll come back at 11:03. right, let's get started again. First, I think we'll just go to a quick video from Skyline.
Hi, my name is Ophelia. I'm a communication specialist at UBS. As part of my role, I manage external communications, and that includes media liaison, journalist relationships, and myself and the team also manage community impact in Australia and New Zealand. So that involves grant giving to various charities and also volunteering. My biggest career highlight to date is probably managing to transition between one industry and the other. And so when I started off, I was working in luxury fashion and lifestyle, and I made the change to financial services.
Cool. So that's one of the people working with UBS, which is our sponsor. Oops. I think we're just doing one video. Okay, cool. So now we're moving on to algebra. Things will be getting a little bit harder from here on. So here are some geometry basics. So the distance between 2 points. You can remember this because it kind of looks like Pythagoras, and that's how we get the distance of a hypotenuse. So this is like saying C equals A squared plus B squared, which we get from C squared equals A squared plus B squared, of course. Gradient is rise over run, so it has to be a fraction. And some people get mixed between all of these. So basically, if you remember that rise over run will be a fraction and the midpoint will be a coordinate. Are these on the formula sheet? I don't think so. Do you know if they're on the formula sheet, Arne?
I'm not sure, actually. I will have a look.
Yeah, cool. I will have a look. Most of the things on the formula sheet are like gradients, derivatives and things like that. Factor theorem is also a really important part of the study design. So factor theorem says that when x minus c is a factor of x, so some polynomial f of x, the factor of f of x, sorry, then f of c equals 0. So if we want to find the factors of this function here, we need to try different values of c and then try and get it to equal 0. So if we say f of 1, we'll get 1 cubed plus 2 times 1 squared minus 1 minus 2. That's equals to 3 minus 3, which is 0. And that means that x minus 1 is a factor of f of x. And then we can keep doing that to get more factors, or we can use long division and divide that polynomial by that factor. So let me just move this to the side. Okay. So long division will look like this. So we know x minus 1 is a factor. So we do x cubed divided by x is x squared. We'll write negative down here in a bracket. X squared times x is x cubed. X squared times negative 1 is negative x squared. And then we'll minus these two. So 2x squared minus x squared, 3x squared. Bring down the negative x, minus x. And then x squared, 3x squared divided by x minus 1. That'll give you 3x. 3x times x is 3x squared. 3x times negative 1 is negative 3x. I forgot the negative 2. Where did I forget the negative 2? I think it's fine. So negative x minus 3x. Or we bring the negative 2 at the end. Yep. That'll be 2x. Bring the negative 2 down. We get 2x minus 2. And then 2x divided by x is plus 2. 2 times x is 2x. 2 times negative 1 is negative 2. And we're left with 0 remainder. So f of x equals x minus 1 times x squared plus 3x plus 2. And now, since that's a quadratic, we know how to factorize that. So that'll be x plus 2 times x plus 1. And now we've found the factors of f of x. Cool. Solving exponentials. So there's two main forms that you'll get for solving exponentials. So one is when it's actually secretly a quadratic, and one is when it's just in exponential form. So if you get something where it's something to the 2x and something to the x, this is secretly a quadratic. So we can write it like this. What we have to do is let u equal e to the x. So we get 5u squared plus 5u minus 6 equals 0. Then if we want to factorize that, 5 times negative 6 is negative 30. Just trying to do it in my head. Or we can use a calculator. So another thing to be really proficient in is how to use your calculator. And what we get, so this would be exam 2, tech active. We would get u equals negative 5 plus or minus root 145 on 10. And then we can make that e to the x equals that, and then solve on the calculator. You definitely wouldn't have to do this by hand. And only one of these will work. So since e to the x has to be positive, the negative 5 minus root 145, that'll be negative. So we only take e to the x. Oh, sorry, that's because of the 5. That 5 is not supposed to be there. Okay, that's a typo on my end. But if it was like this, we would only take 5 plus root 145 on 10. And then we could solve for x on the calculator. That would be an exam 2 question. How we do this question is we want to make the bases the same. So 3 to the power of 3 minus 2x equals, since that's a base 9, we want to make that a base 3. So 3 to the power of 2 to the power of 4. 3 to the power of 3 minus x equals 3 to the power of, and then we do 2 times 4, so that's 8. And so 3 minus 3x equals 8, because we just equate the powers. We have negative 5 equals negative 3x. Wait, no, sorry. 5 equals negative 3x. X equals negative 513. Okay, cool. All right, we'll give everyone a couple minutes to have a go at this. And this is actually in one of the two forms that we just discussed. Yep, we have a question. Is this from exam 1? Yes, this is an exam 1 question. So the E1 means exam 1. All right, let's have it go. So first thing we want to do is we identify, oh, this is that type of exponential where it's secretly a quadratic. So when we solve quadratics, we want to bring everything over to one side. So we get 3e to the t minus 5 minus e to the negative t equals 0. And right now it's not looking like a quadratic. So what we're going to do is we're going to times both sides by e to the t. So we get 3e to the 2t minus 5e to the t minus 8. Okay. So now it's looking a little bit more like a quadratic. So this is 3 times e to the t squared minus 5 times e to the t minus 8, I would say equal to 0, minus 8 equals 0. Let u equal e to the t. Then we have 3u squared minus 5u minus 8 equals 0. And then do 3 times negative 8 is negative 24. We want to find two numbers that multiply to get negative 24 and which add to get negative 5. So that is 3 and negative 8. So 3 and negative 8. So the way that we write that for this factorizing quadratics, 3u squared plus 3u minus 8u minus 8 equals 0. 3u times u plus 1 minus 8. Factorize out the 8, we get u plus 1 equals 0. And then we have 3u minus 8 times u plus 1. So that's a method of factorizing that we haven't discussed. But if, for example, this is an example of if you don't understand it, try and look back into your textbook. You might look into year 10 or year 11 to find how to factorize quadratics when the a value is not 1. Okay. Now, when we get to here, we use null factor law. So u equals 8 on 3 and u equals negative 1. E to the t equals 8 on 3. E to the t equals negative 1. Now, I'm going to say that this is not possible. Why isn't it possible? Good. So you need to do a log to find it, and you can't have a negative in the log. So we'll go with e to the t equals 8 on 3. And then we log both sides, and we get log e of 8 on 3 equals t. Now, if we had e to the t equals -1, we get log e of -1 equals t. But that's not possible because we can't have a negative in the log. So we discount that, and this is your answer. All right. We had a question, what's the name of the method of factorization you've used? I'm not sure what the name is, but it's basically, there's two ways of factorizing quadratics. There's the way where a equals 1, which is just the first number, equals 1. And then there's the way when a does not equal 1. So when it's like a number bigger than 1. Not sure about the name. Solving logs. So we want to do our domains first. So the most important thing with logs, they try and trip you up by getting you to find answers that are not in the domain of the question. So we know that logs have to have a domain that's greater than 0, which means 6 minus x has to be greater than 0. And so 6 is greater than x, which means x is less than 6. Also, 4 minus x has to be greater than 0. So 4 is greater than x is less than 4. Now, we've got two domains. We need to find where they intersect. So if we had x equals 5, that would work for this one, but it wouldn't work for this one. So the domain that encompasses everything is going to be x is less than 4. Another way we can write that is to draw it on a number line. So if we have 4 and 6, and we have like 0 and 8, this first domain is x is less than 6, so we can write it like this. And the second domain is x is less than 4, so we can write it like that. And the intersection of both of those, so that's the part where both the lines exist on that number line, is this. So that is x is less than 4. That's the intersection. Cool. So the domain for this entire equation is x is less than 4. Now we put it all together. So using our log rules, we know that this is equal to log 2 of 6 minus x over 4 minus x equals 2. Then we do, so my teacher called it circle rule. 2 to the power of 2 equals whatever's in the brackets. So 2 to the power of 2 equals 6 minus x over 4 minus x. 4 equals 6 minus x over 4 minus x. 16 minus 4x equals 6 minus x. 10 equals 3x. X equals 10 on 3. Cool. Let me just make sure that's all correct. Yep. Cool. Does that make sense to everyone? Yep. And the last thing we do is just make sure it's in our domain. So x is less than 4. Yeah, this is 3 1/3, so it is in our domain. Cool. Pop quiz. Who is the half-blood prince? Good. Most people got it right. It is Severus Snape. Good. Cool. All right. Solving trig and circular functions. So these are your exact values. You can either use the table method or you can use the triangles. I like to use the triangles. We won't go through them today, but I'll give you like a couple seconds to screenshot if you want. All right. So the first thing we do when we talk about trig is we want to look at our domains. So remember, that's one of the most important things in methods. They always try and trick you with the domains. So we'll highlight the domain. And then we look at the angle. So our angle is 2x, but our domain is given in x. So what I'm going to do is I'm going to say 2x is an element of. Then we're going to multiply each of these numbers by 2. So 0 and 2 pi. So that is the domain that we'll be solving our function in. And then at the end, we can convert back to x. Okay, now we're going to solve in the domain. So 1 minus root 2 sine of 2x equals 0. Negative root 2 sine of 2x equals negative 1. Sine of 2x equals 1 on root 2. Now, does anyone know what 2x will equal? In our domain of 0 to 2 pi. Yep, we've got pi on 4. Are there any other solutions in 0 to 2 pi? Good. Pi on 4 and 3 pi on 4. So the way that I do this is I draw it on the unit circle. I say, okay, sine is positive. So we have this first quadrant and the second quadrant. And we know that this angle is pi on 4 and this angle is 3 pi on 4. And we know it's the first and second quadrant because sine is positive in the first and second quadrant because it's all stations to Caulfield. So all of them, all 3 trig values are positive in the first quadrant, and then sine is positive in this one, tan is positive in this one, and cos is positive in the bottom right. So 2x is equal to pi on 4 and 3 pi on 4. Now we finally solve for x. So x is equal to, and we divide both sides by 2. We'll do that separately. So x is equal to pi on 8 and 3 pi on 8. Cool. All right, I'll give you guys a few seconds to do this one. So solve the following where x is between 0 and 2 pi. All right, let's have a go. This one's a little bit harder. So the first thing we want to do is find the domain. So our original domain is x is between 0 and 2 pi. So 3x is going to be between 0 and 6 pi. Next thing we want to do is solve for 3x. So we have sine of 3x equals negative root 2 on 2. And we know that 3x will be equal to, what would 3x be equal to? From 0 to 6 pi. Does anyone know? Yeah, so yes, there are a lot of answers for this one actually. Good, and we have to list all of them. So we know that it's going to be first and second quadrant. So we'll get, oh, sorry, not first and second, third and fourth quadrant, because the sign is negative. So we have 5 pi on 4 and 7 pi on 4. Then we go around again. So this will be 3 pi plus pi on 4, which will be 13 pi on 4 and 15 pi on 4. And then we'll get to 4 pi. So go around once, you get to 2 pi. Go around twice, you get to 4 pi. Go around a third time, we'll get 21 pi on 4 and 23 pi on 4. And then that's when we reach 6 pi at the end. So this is our list of values of 3x. The way that I do it, in my head, I just kind of go in a spiral. So 0 to pi, and then that is 5 pi on 4. And then you hit 7 pi on 4. Then you keep going. You go back, you hit 13 pi on 4. Then you hit 15 pi on 4. Then you keep going, and you hit 21 pi on 4 and 23 pi on 4. And then you get to 6 pi and you stop. So we have 5 pi on 4, 7 pi on 4, 13 pi on 4, 15 pi on 4, 21 pi on 4, 23 pi on 4. And then third step was solve for x. So we have 5 pi. So we divide everything by 3. We could just write it as 5 pi on 12, 7 pi on 12, 13 pi on 12, 15 pi on 12, 21 pi on 12, and 23 pi on 12. So we had a question, how did we get 13 and 15 pi on 4? So the way that I did that is, let me just rub this out. The way that I did that, so I start from the 0. Rub this out a bit more. So I start from an angle of 0. And you go around to 5 pi on 4. Then you get 7 pi on 4. And then you go back around. So once we reach this point again, that's 2 pi. Once we go around once, we get to 2 pi. And then you add another pi to reach here. And then you add pi on 4 to get 13 pi on 4. So once we reach here, that's 3 pi, which is 12 pi on 4. And then you add pi on 4, which is this base angle here, to get 13 pi on 4. And then same thing with the 15 pi on 4. This will be, once we get back to here, that's 4 pi. And you minus 1 to get pi on 4. To get 15 pi on 4. And then you do the same for 21 and 23. We had another question. Why does it start with 5 pi on 4? I thought it'd be negative pi on 4. So negative pi on 4 would be if your domain went into the negatives, but our domain starts at 0. It doesn't start at negative pi. Is this exam 1? Yeah, this could be exam 1. They'd give you a few marks for it, but it definitely could be exam 1. Okay, so that one was a little bit harder. All right, inverse functions. For an inverse function to exist, the original function must be 1-to-1. And if it's 1-to-1, that means it passes the horizontal line test. So if we draw a horizontal line and it cuts the graph more than once, then it fails. If we draw a horizontal line and it passes only once, then it crosses only once, then it passes. And therefore we can use the inverse function. How to find the inverse? So we actually have to use a few steps. It's like doing your driving test. You really have to show the examiner that you're doing these things to get the full marks. So we literally write let y equal f of x because y actually hasn't been defined in our graph yet. So we need to write let y equal f of x. Then we'll literally write swap x and y. Some schools say, oops, sorry, my handwriting. Some schools just say x, y, just to swap them. So you need to have both of these things to get full marks. Then once you've swapped them, so you say x equals y minus 1 cubed, we want to solve for y. So we'll cube root both sides. We get x to the power of 1/3 equals y minus 1. And y equals x to the power of 1/3 plus 1. And another really important thing is if it says define the function f inverse, we need to have the domain in there. Does anyone know how to get the domain of an inverse? Good. It's the range of the original function. So if we know how to graph this, we know that this is in stationary, not stationary point. It's in point of inflection form. So the graph will look like this. The range of f of x is all real numbers. Therefore, the domain of f inverse is going to be all real numbers. So if we define our function, we'll say f inverse such that our domain is real, codomain is all real numbers, comma, f inverse of x equals x to the 1/3 plus 1. Cool. All right, we'll give you guys a few minutes to have a go at this one. All right, let's have a go. Sorry, I know it's not enough time, but we're running a little bit behind schedule. So state the rule and the domain of F inverse. Now, since they have a domain in the question, we're going to highlight that. First thing we do, let y equals f of x. Then we say swap x and y, and we'll say this in every single question, every single inverse question we get, just in case the examiner is really picky. So x equals 1 over bracket and y minus 2 squared. We'll multiply both sides by y minus 2 squared. So we get x times y minus 2 squared equals 1. Then divide both sides by x. So we have y minus 2 squared equals 1 over x. Then what we do is we'll square root both sides. So we get y minus 2 equals root 1 over root x. And we know that root 1 is just 1. Then we'll plus 2 to both sides, so we get y equals 1 on root x plus 2. So that's the rule. The domain, as we said last time, is from the range of the original. So if we're going to graph this, we know that the graph starts at 2 and goes to infinity. And this is a hyperbola. So it'll have an asymptote at x equals 2 and at y equals 0. And it'll look like that. Can anyone tell me what the range of that graph is, the original? Cool. So the range is 0 to infinity. So range of the original is 0 to infinity with round brackets. That means the domain of the inverse is 0 to infinity. And the rule for the inverse is 1 over root x plus 2. Sorry, not a hyperbola, it's a truncus. But it would look like that. Either way, we get the same range. Yeah. Cool. So we don't actually have to write it in that original form with the F inverse such that blah, 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 because they're looking for the rule, which is this one, and the domain, which is this one. Cool. Composite functions. So I like to think of composite functions like a machine. So x goes in for normal functions, x goes in, it gets transformed by a function and it comes out as y. So if we put an x value in of 1, we'll transform it. So 2 times 1 is 1, plus 1, 2 times 1 is 2, sorry, plus 1 is 3. So the y value is 3. For composite functions, we don't just stop at f of x, we put another function after that. So if we have 1 and we get 3 as our y value, this new y value becomes our x value again. So now x equals 3, we put it into g of x, so we get 3 squared, and y equals 9. That would be for the function g of f of x. So our inner function is first, and then our outer function is last. So I'll just quickly go through these. So g of f of 2, we'll put 2 in first because that's our x value, x equals 2. And when we put it into the f function, we get y equals 2 times 2 is 4, plus 1 is 5. Then that becomes our new x value. So x equals 5, we'll square it, and we get y equals 25. So y equals 25. And same thing with that, but we'll skip that because we're running out of time. And we'll give you guys a few seconds to have a go at this on Menti. Is the Menti working?
Oh, is it not working right now?
It just says question 6 of 18.
Oh, I pressed start quiz.
Let me try.
Let's
Okay,
see if
there
I
we
can
go.
restart it or something.
Oh, no, all good, all
Oh.
good. Got it. Ah, that's weird. Oh, yeah.
All right, there you go.
Yeah. All right, let's see how people went. E, very good. Everyone's so smart. Okay, so for anyone who didn't really get it, so f of g of 3 means g is on the inside and f is on the outside. So our original x value is 3. And once we put in 3 into g, we'll get 2 as our answer. So y equals 2. And that becomes our new x value, x equals 2. Put that into f, we get y equals 5. So E. All right. Since we're running a little bit behind schedule. Let's just say we'll do a 10-minute break because you guys deserve it. So we'll come back at 11:48, and you can type in some questions into the Q&A on Menti, and we'll try and answer them when you come back. Just while we're waiting for people to get back, 11:48 is when we'll start again. But if anyone's still here, what subjects is everyone doing? Is anyone doing special as well? Got economics, chem methods, special bio, politics. Cool. We got a good spread. I found that at least from people I talk to, people do methods tend to do like kind of the sciencey kind of subjects, a little bit of humanities, but we've got a good spread, I think. It's got some Ing Lang accounting, soft dev. We might ask Hugh a question. Is that all right?
Yeah, sure thing.
Which subject, if any, do you think helps you the most in your career at the moment?
Well, it's a good question. It was quite some time ago. I actually do think the maths ones are really helpful. So working in finance now, we don't do quadratics and cubics day to day, but I think methods in particular it's a very logical based subject. Going back to your point around what are we trying to solve for, what's in the toolkit, and so a lot of the problems we face in finance and finding financial outcomes for companies that have questions, it's a very logic-based process, and methods is a really good subject, and it's one that it's just a matter of spending time practicing and seeing the questions and building up the logic pattern, that once you've done that enough, then you can apply it to lots and lots of different solutions. I think methods, like you, I did a lot of methods in spec and chemistry and a lot of those types of subjects, all because they were sort of subjects that were logic based, but they're all collectively, and the thought pattern behind it have been really helpful in finance, and for none other the fact that finance is all about numbers and interpreting numbers and trying to problem solve.
Cool. So if anyone's interested in finance and logic-based kind of careers, then methods is the right choice. Cool. All right, let's have a look at some Q&A questions. What would be the best way to spend the last few weeks before methods exam? So I think the best way is to do practice exams, and then while you're doing practice exams, revise the topics that you are getting wrong on the practice. So you'll always be getting something wrong at least on the practice exam, and that's completely fine. It just tells you which topics to revise from your textbook. So if you, for example, forget how to do a certain type of differentiation, then you go back to your textbook, learn it, redo the question on the exam, and then in like a week or so, redo the whole exam. Just see how much you improve. And that also reinforces the things that you learned when you did the exam the first time. So practice exams, I think, would be the most important way of revising. And then supplementing those practice exams with revising the topics that you're struggling a bit with. Cool. Answered. In what order would you recommend to start with in exam 2? So this is another reason to do lots of practice exams. Just figure out what works for you. So if you find that you can whiz through a multi-choice during reading time and just remember your answers and then tick them off, then do that. If you think that doing short answer first would be better, you can just guess some multi-choice, then do that. It's really up to you. But the only way you'd know is if you practice it to time. How to best tackle time pressure, especially in exam 1. Don't be afraid of skipping questions that look insanely difficult, because the difficulty to mark ratio is not always even. So sometimes you'll get 1 mark for doing an insane amount of work, and which is insanely difficult. And other times you'll get a mark for doing something that's so easy. So you really need to, if you're running out of time, just pick the marks that you do. You don't have to do everything. And that's another good reason to really pay attention during reading time. What are the easy questions? What are the hard questions? Do the easy questions first. Make sure you get as many marks as possible. I'll answer one more question. What is the order we should apply transformations? So if they tell you a specific order, then do the order that they tell you. If they don't, then do dilations, reflections, translations. So Dr. T, DRT. All right, let's continue. So differential calculus, this is all about derivatives. So we'll be going through how to find the derivative first. So a derivative tells you the gradient or slope at a certain point on a graph. And it's important to know the notation and the wording for some of these. So the original function is f of x, and we derive it, so that's the verb, to get the derivative, that's the noun. How do I find a gradient? So the original function gives you the y value. The derivative function gives you the gradient. So to find the gradient, we need to find the derivative. Okay, if the original function is x squared, and we want to find the gradient on the graph at x equals 2, first thing we're going to do is decide, what does the question want? The question wants a gradient. What do we have? We have a graph and an x value. How are we going to get there? We need to use a differentiation rule, which we'll go through later, to differentiate the original and then sub in x and find a gradient. So let's do that. What rule are we using to differentiate? We're going to use power rule. So y equals x squared, therefore dy dx equals 2x. And this is just another notation. Since it's giving it to us in y equals something, we'll be writing as dy dx instead of as f dash of x, but you can do either. Yep, so that's the second step, differentiate. And now we use the derivative to find the gradient. And to do that, we have to sub in the x value. So let x equal 2, dy dx equals 2 times 2, which is 4. All right, not too bad so far. These are the formulas. They are all in your formula sheet. But by the time the exam comes around, you should be able to memorize most of these because you'll be doing the exams a lot. If you don't, that's completely fine. The formula sheet is always there. Just remember what is in the formula sheet and what isn't. If something is not in the formula sheet, you will have to remember it. So you can easily just look up methods formula sheet and it'll show you. You get it in exam 1 and exam 2. Chain rule. So there's 2 ways of doing chain rule. I like to do the method of dy du and du dx, but we'll also be talking about the other method, which is to diff the outside and then diff the inside. So first thing we want to do is identify the inside function. So the inside function is u, and it's this, in this case, it's x squared minus 1. So u equals x squared minus 1. And then we write y in terms of u. So y equals x squared minus 1 is cubed. So y equals u cubed. Then what we do is we find dy du. So dy du equals, so that'll be 3u squared, and du dx, which is 2x. Sorry, my pen's not working. There we go. Then we use this formula, dy dx equals dy du times du dx. So dy dx equals dy du times du dx. And the way that you can remember that is because you can just cancel the du's and you're left with dy on dx. But we're going to sub in the dy du. So that's 3u squared. And then we'll sub in the du dx. So that's 2x. And then we have 3u squared times 2x. And since we want it all in terms of x, we're going to sub the u back in. So 3 times x squared minus 1 times 2x. Cool. So the reasons I would use this is if the function looks a little bit wacky and we can't really figure out what's the inside function, what's the outside function, then I would use this method. However, if the question is a little bit easier and we just want to do it in one step, we can say differentiate the inside function and we times it by the derivative of the outside function. So the inside function derivative would be 2x. The outside function derivative would be 3 times x squared minus 1. And then we just times that by the derivative of the inside. Cool. All right. We'll give you guys a few minutes to have a go at this. And you can choose whichever method you want. I'll just write out the formula. So we have dy dx equals dy du times du dx. So I had a question, is this units 3 and 4 methods? Yep, definitely. These are the questions that you'll see on exam 1. Can any of them be y and u? I'm not sure what you mean by that. Like, can you swap them around and the answer would be the same? How do you determine the inside function? I'm not sure. Can you swap them around the answer? Oh, do you mean can you use u instead of y? I would probably use y as your overall function and u as the inside. Yeah. Would you lose marks if you don't simplify the answer? No. So it depends how many marks there are. But if there's a really easy simplification, then you'd simplify it. Otherwise, I would just leave it how it is. All right, let's have a go. So what I'm going to do is I'll say identify the inside function. So we have let u equals negative 3x cubed plus x squared minus 64. That means y equals u to the power of 3. dy du equals 3u squared. du dx equals negative 9x squared plus 2x. And then dy dx equals 3u squared times negative 9x squared plus 2x. And then what we do is we sub in the u back in. So that's equal to 3 times negative 3x cubed plus x squared minus 64 times negative x squared plus 2x. Cool. Does everyone understand that? Yep. All right, have a go at this question. That'll be on Menti. All right, 10 seconds left. Cool. So most people chose A, which is the correct answer. So, all right. So the reason it's A is, so I'll use the second method this time. So deriving the inside and then deriving the outside. So the derivative of the inside will be K times E to the KX, and the derivative of the outside will be G dash of E to the KX. And we multiply those together and you get A, because you just rearrange it. So that's K times G dash of E to the KX times E to the KX. Cool. Product rule and quotient rule. These are very important. We'll have a go at this together. So what we do is we say so we'll just write out the product rule here. So the most important thing is figuring out if you're using product rule or quotient rule, and we're using product rule here. So that's U dash V plus UV dash. So what I do is I just write UV plus UV, and you put the dashes on the letters on the outside. So U equals X squared, V equals E to the 5X, U dash equals 2X, V dash equals 5 times E to the 5X. And so we get F dash of X equals U dash, which is 2X, times V, which is E to the 5X, plus U, which is X squared, times 5 E to the 5X. And if it was just saying find F dash of X, you don't have to simplify. But since we have F dash of 1, we'll just sub in 1. So 2 times E to the 5 plus 1 times 5 E to the 5 equals 2 times E to the 5 plus 5 E to the 5 equals 7 E to the 5. Cool. All right, next pop quiz. Which phase are we up to in the MCU? Actually, I had to look this up because I didn't remember. Good job. Okay, most people got 4 or 5, but we're actually in phase 4. Cool. How do I find the equation of a tangent? So to find the equation of a straight line, you must find 2 things, a gradient and a coordinate. So if we want to find the equation of a tangent at y equals x squared at x equals 2, that's this line here. If I could draw that straight, like that. So the first thing we want to do is find the gradient at x equals 2. So we'll say dy dx equals 2x, let x equals 2, dy dx equals 4. Okay, that's the gradient of that tangent. Find the coordinate at x equals 2. So y equals 2 squared equals 4. So the coordinate is 2, 4. Now we can either use y minus y1 equals m times x minus x1, or we can use y equals mx plus c. Let's use that first method. So y1 and x1 are these coordinates here. So y minus 4 equals gradient, so that's 4. That's the gradient, times x minus 2. So we have y equals 4x minus 8 plus 4, y equals 4x minus 4. And if we look at our graph, that makes sense because this line will probably hit the y-axis at -4. Cool. That's how you find a tangent. Okay. Sorry. Find the equation of a tangent at this point. This one's a little bit harder. So we had a question in the chat on the unit circle, is cos the x or the y coordinate? So on the unit circle, cos is going to give us the x coordinate. So if this coordinate was 1, 0, that means that, and the angle is 0, that means cos of 0 will give us the x coordinate, which is 1. Okay, let's have a go at this question. Find the equation of the tangent at the point that. Okay, this one is a little bit harder. So remember, what do we want? We want the equation of a tangent. What do we have? We have a graph and a point. How are we going to get there? Well, we need to diff the graph and use our formula to find the equation of the tangent using the gradient and the point. Okay, so first step is to diff the graph. dy dx equals, and we're going to use product rule. So u equals 1, x, v equals sine of x, u dash equals 1, v dash equals cos of x. So dy dx will be u dash, which is 1, times v, which is sine of x, plus u, which is x, times v dash, which is cos of x. And so we'll just rewrite that as sine of x plus x cos of x. Then what we do is we want to find, remember, we need to find the gradient and a point. So right now we've got the derivative, but we don't have the gradient of the graph yet. So we're going to use the derivative to find that gradient. So we'll say let x equal the x value on this coordinate. So let x equal -5 pi on 2. That means that the gradient is equal to sine of 5 pi on 2 plus negative 5 pi on 2 times cos of negative 5 pi on 2. All right. So how do we find what sine of negative 5 pi on 2 is? Okay. First thing we do, we figure out where on the unit circle that is. So we'll go negative 5 pi on 2 is negative 4 pi on 2, which is negative 2 pi. So negative 5 pi on 2 equals negative 4 pi on 2 minus pi on 2. And we know that negative 4 pi on 2 is negative 2 pi minus pi on 2. So we'll go backwards. So go backwards like that to get to negative 2 pi. Then we go another negative pi on 2. So the location is here. And the sine value of that location is going to be negative 1 because sine is our y coordinate. So sine of negative 5 pi on 2 is negative 1 plus negative 5 pi on 2 times cos of negative 5 pi on 2. So as we said before, cos is the x value. So that's 0. And so our gradient is equal to negative 1. Cool. Now that we have the gradient and we have a point, which is negative 5 pi on 2 comma 5 pi on 2, we can find our equation of the tangent. So I'm going to use this formula, y equals mx plus c. Y equals negative x, because the gradient's negative 1, plus c. And then we'll sub in this point. So 5 pi on 2 equals negative 5 pi on 2. Sorry, negative 5 pi on 2 plus c. So c equals 0, because that'll be positive 5 pi on 2. And so we get y equals negative x, and that's our final answer. So it's a lot of working for 2 marks. So you might decide on your exam that this question isn't worth the 2 marks if you're running out of time. So it's just a lot of things to take into consideration during your reading time. We'll skip this question because we're running out of time. Average rate of change, instantaneous rate of change, and average value. So a lot of people get these mixed up. Average rate of change is when you have 2 points and you're getting the gradient between those 2 points. That's why we use rise over run. That's the average rate of change. The instantaneous rate of change happens at 1 point. So this is when we use the gradient, but instead of using rise over run, we use the derivative. So let me write this in. So this is gradient at 2 points. This is instantaneous gradient, so we're using the derivative. Average value is the average y value over a certain stretch of graph. The way that we get that is we get the area and then divided by the x distance. So you end up making this little rectangle. And the rectangle is the area, the same area as the graph, but it's when you squash it down so that it's flat. So that gives you the average y value of the graph. Okay, we'll give you a few seconds to have, or a minute or so to have a go at this question, and you can use your calculator because this is exam 2. And remember to go on Menti for this. All right. I think we'll skip the last 20 seconds, just in the interest of time. Oh, I don't know if that worked. Sorry. But yeah, there we go. The answer is E, which most people got. Good. So the way we get it is we identify this is average rate of change. So that's that want question. What do we want? We want the average rate of change. When I was doing this, when I was practicing, I did it and I was like, oh wait, I accidentally got the average value. So it's very common, even myself, who I've been doing this for years, I went like, oh, whoops, that's the average value, not the average rate of change. So make sure you highlight rate of change. So the way that we do this is we use our formula. So it's between 2 points. So we do, we'll do it like this. So 1 comma f of 1, that's our first point. And 3 comma f of 3 is our second point. So we do y2 minus y1. So f of 3 minus f of 1 over 3 minus 1. And then if we define f of x on our calculator, we can just chuck that into the calculator and then we'll get 9. Cool. All right, we'll have a quick 5-minute break. So we'll see you back here at 12:25. I think we're catching up for time, which is good. All right, welcome back, everyone. Hope you had a good stretch. Okay, evaluating integrals. So these are on the formula sheet once again. So make sure you've got the formula sheet handy. So a quick tip when you're doing trigonometric integration and differentiation. We know that sine goes to cos when you're differentiating. When you do, when you anti-derive, obviously it'll go in the opposite direction. So cos to sine, and deriving cos goes to negative sine and negative sine goes to cos. One way I like to think about it is on the unit circle. So say we have positive cos here, positive sine, and negative cos and negative sine. When we're differentiating, we go clockwise. So sine becomes cos, just like this one. Cos becomes negative sine, just like this one, etc. So negative sine becomes negative cos, and negative cos becomes sine. That's when you're differentiating. And then integrating, as we know, is just the opposite of that. So if we want to integrate cos, we will get sine. If we want to integrate sine, we'll get negative cos. If we want to integrate negative cos, we'll get negative sine, etc. So that's a good tip. Cool. Indefinite integrals. Indefinite integrals are when there are no terminals. So there's no b and there's no a. So this is when we just want to find this formula. So first thing we do, we decide which formula on the formula sheet that we're going to use. Don't forget your plus c and the dx, because you can lose marks for that. And then sub in a point to find c. This won't always be applicable. For example, if it says find the integral, or if it says integrate, then you have a plus c. If it says find an integral or find an antiderivative, then you don't have to put a plus c. You can just sub in c equals 0, and that is one of the antiderivatives. So we'll have a go at that. We'll give you a few minutes to have a go at this question. We had a question, is it possible to send the PowerPoint with your annotation? Sorry, but I'm doing the annotations because Google Slides doesn't allow annotations. So I'm doing the annotations on Zoom, and therefore it doesn't actually save those annotations. But there are lots of videos online going through exam questions with annotations. So I think there's Worms Academy on YouTube. He does like a video for each exam. So that's pretty good. Yes, you get the recording, and they will be coming to your emails, I believe, within the next week. Yep, and there was another suggestion. You can screenshot the pages and just save it in your like OneNote or your Word or something like that. All right, let's give this one a shot. So this one's a little bit harder. Let f dash of x equal 1 minus 3 on x, where x is greater than 0. Given that f of e equals -2, find f of x. So this is a classic exam 1 question. And if you can do this, you can get an easy 3 marks on the exam. It's not easy to begin with, but once you can practice it, it'll be easy. So first thing we do is we identify which formula to use on the formula sheet, and I've pasted this in for you in the top right. So this is going to turn into a log because we've got something over x. So f of x is going to be the integral of f dash of x. So we have the integral of 1 minus 3 on x dx, which is the integral of x. What's the integral of, sorry, the integral of 1. What's the integral of 1? X, easy. What is the integral of -3 on x? Good. So -3 log e of absolute value of x. Sorry, I shouldn't have that there. And then plus c. Okay, so we have the absolute value because whenever we're integrating to get a log, we always have to have that absolute value until we know the domain. Since we know that x is greater than 0, we can make that into round brackets. So x minus 3 log e of x plus c. We always remember our dx and we always remember our plus c. You had a question, I thought absolute values are only used in spec. I think in your working, it's good to have absolute values in your methods, but for your final answer, you don't have to have the absolute value. What does absolute value mean? Absolute value are these straight, they're not really brackets, they're like straight lines. And all it means is take the positive of whatever is inside them. So if you had absolute value of -2, that's equal to 2. You just take the positive. And if the domain is x is greater than 0, then we use positive x. If the domain is x is less than 0, then we use negative x. And it just makes sure that whatever's in the log is positive. When do you use it? You use it when you're integrating 1 on x to get a log. So that should have the absolute value lines. That's why they've said when x is greater than 0, then you don't have to have that absolute value. You can just use the brackets. When x is less than 0, they will have log e of -x plus c. So basically, the absolute value is used when you don't know what the domain is. So if you know the domain is positive, then you can use that first one. If you know the domain is negative, then you use that second one. All right. Next thing we do is sub in the point. So f of e equals -2. So -2 equals e minus 3 log e of e plus c. -2 equals e minus 3, and log e of e is 1 plus c. So -2 equals e minus 3 plus c. And so we get 1 minus e equals c. And so f of x equals x minus 3 log e of x plus 1 minus e. Okay. Cool. Is everyone comfortable with that? Yep. Cool. People comfortable. Awesome. Integration by recognition. So this is a very common question on exam 1 again. The way that you recognize it is they will say differentiate something and hence integrate something. And the hence is really important because it means you have to use that first part of the question. So first thing we're going to do is we're going to differentiate this. So I'll just do that quickly. We're using product rule. So dy dx equals derivative of the first one times the second one plus the first one times the derivative of the second one. So sine of x plus x cos of x. Cool. So first thing we do after differentiating is line them up. So what I mean by that is just line it up like this. Actually, it'll probably be better to write it like this. ddx of, let me just move that a little bit. ddx of x sine of x equals sine of x times x cos of x. Then what we do, I'm just going to move this to the middle here. Then what we do is we integrate both sides. So integrate, sorry for my handwriting. Now, what is the integral of the derivative of x sine of x? The integral of the derivative of something. Yep, so we have x sine x, good. So when we integrate the derivative of something, we're just going to end up with the original, because integration and differentiation, they're the opposites. So the integral gets cancelled with the derivative, and we're left with x sine of x. And we have to have a plus c because technically we did just do an integration. So the integral and the derivative cancel each other. And what we're left with is integral of sine of x plus x cos of x. So we've integrated lined them up, we've integrated both sides. Now we rearrange for what we're trying to find. So this is what we want. We want the integral of x cos of x. And that's this one. So what we're going to do is we want to get that by itself on one side. So we're going to split up the integral. So we have x sine of x, keep the left side the same, equals integral of sine of x dx plus integral of x cos of x dx. All right, now we'll minus the integral of sine of x from both sides. So x sine of x minus integral sine of x dx equals integral, so that's an x, integral x cos of x. And we know that the integral of sine of x is, if we use our unit circle, so sine of x is up here. And to integrate, we go anti-clockwise. So we'll get negative cos of x. So we have x sine of x minus negative cos of x equals integral of x cos of x dx. And that's x sine of x plus x cos of x equals integral x cos of x. Cool. The plus c, what we did was we just said, actually, let's leave it in. And then at the end, we'll say, let's c equals 0. And then we could just get that without the plus c. Cool. All right. So first, I'll do this question with you, and then the next question will be an integral using this. So dy dx equals 1 times log e of 3x plus derivative, we have x, and the derivative of log e of 3x is going to be just 1 on x. Because the derivative of log e of ax, if we look in the formula sheet, is just 1 on x. And so we have log e of 3x plus 1. Okay, now we'll go to the next slide. We'll move this over here. We'll delete that. Have a go at this question. Now that we know that the derivative is log e of 3x plus 1. So there was a question, what happened to 3? Let me explain that while you guys are doing that. So log e of 3x, that would be 1 over 3x times, because this is chain rule, we have to multiply by the derivative of the inside. So we times by 3, and the 3's cancel out to get 1 on x. All right, let's have a go. So remember, our first step was to line up the previous answer. So d dx of, what was it? X log e of 3x equals log e of 3x plus 1. Then we integrate both sides. The integral and the derivative cancel. We get x log e of 3x plus c equals integral log e of 3x plus 1 dx. And then we decide, what are we trying to isolate here? We're trying to isolate the log e of 3x. So we'll write x log e of 3x plus c equals, and we'll split up that integral. So log e of 3x dx plus 1 dx, integral of 1 dx. And we know that this is just x. So we have x log e of 3x plus c equals integral log e of 3x dx plus x. And then integral log e of 3x dx equals x log e of 3x minus x plus c. All right. Do we have any questions with that? Cool. All right. So it's a little bit harder. But when you practice these integration by recognition, you'll get better and better. And there's lots and lots on the on that worksheet Weebly page that we sent at the start of the session. Will you lose a mark if you don't include the plus c? I think so. Because the plus c, it doesn't actually say find an antiderivative. It says calculate the integral here. So I think you should have the plus c at the end. It's probably one of those things where it depends on the examiner though, but I would have it just in case. Okay, definite integrals. These are when they do have terminals, and what you have to do is subtract when you sub in 4. So the integral and you sub in 4 minus the integral when you sub in 1. So decide what formula to use and integrate, sub in the terminals and subtract. So we'll have a go at this one. Actually, we'll just skip to the next one and have a go at this one. So I'll give you a few minutes for this. All right, let's have a go at this. Whoops. That's the next pub quiz. All right. So to integrate this, we will get, so we have 2, and then because we're integrating, we do the opposite of chain rule. So the inside function here is 2x minus 1. The derivative of that is 2. So instead of multiplying, which is what we do when we're doing chain rule, because we're integrating, we do reverse chain rule. So instead of multiplying, we're going to divide by 2. So we have that 2 on the top, then we divide that by that 2 on the bottom, times log e of 2x minus 1, 5 and 4. And because, actually, we'll just go from here. Yep. So now we have to sub in 5 and 4. So log e of 2 times 5 is 10, minus 1 is 9. Minus log e of 8 minus 1 is 7. Sorry. And then using our log rules, we get log e of 9 on 7. So is that where we finish our question? What do you reckon? No, what do we have to do? Good, we have to find b. So the question is asking, find the value of b. So that's definitely something we would highlight at the start. So we'd write b equals 9 on 7. Well done. Pop quiz. Who is this? All right, awesome. Most people got A. So yeah, that's Yondu from Guardians of the Galaxy. All right, area between curves. So the most important thing is to split it up so that you can decide which graph is on top, which graph is on the bottom. So for this graph, we need to split it up into this, this, and this. So if we want to find the area between these curves, there's actually 2 areas that we need to find. So you split it up, integrate, and then evaluate. So what I'll do is I won't go through everything for this one because we're running out of time, but I'll show you how to split it up. So we need to make them equal to each other, equals to x. And then we're lucky because on this graph it actually shows us the coordinates of the point of intersection are -2, -4, and 1, 2, and then 0, 0. So the area 1 will be from -2 to 0. And then we do top minus bottom, so red minus blue dx. Area 2 is 0 to 1 of blue minus red. And then once we've found those 2 areas, we put them together and we add them together and find the total area. All right, we'll give you a few seconds for this one on Menti. This is a tricky one. Oh, sorry. I think the timer on this was only 15 seconds. That's my bad. Yeah. So the answer is E. So what we're actually doing is we're getting the area from 0 to D. So that's the total area underneath that big graph. And then we're minusing the area under the little graph. So that's from A to C. A common mistake that people made on the exam for this one is to go from 0 to B, do the top minus the bottom, and then from B to D, do top minus the bottom. But that doesn't work because there's this little section here, which the bottom graph is actually the x-axis, not G. And here, in that section, the bottom graph is the x-axis again, not G. So we can't do that option. Average value. So if you have the area under the graph and squash it into a rectangle, the average value is how tall that rectangle would be. So if you get this, this graph, the area from 0 to 3, and you squash it into a rectangle, you'll get a height of whatever this value is. That's the average value. So the important question to ask so that you don't get it mixed up with rate of change is, are we looking at average value or the rate of change? So very important to pay attention to that in the question. So the average value over this interval, I'll just do it for us so we can, I'll do it with you guys at the same time. So highlight average value, highlight domain, but that domain is different to the domain they want us to use in the question. So I'd highlight this one in 2 colors maybe, or something like that. Then I would use our average value formula. So average value equals 1 over, what is our B value? Pi on 6, good. And our A value? Negative pi on 3, very good. And then we integrate from pi on 6 to negative pi on 3, or negative pi on 3 to pi on 6, however you say it. And we sub in f of x, so 2 sine 2x minus 1 dx. This is exam 1, so we'll do it by hand. 1 over pi on 6 plus pi on 3 is equal to pi on 6 plus 2 pi on 6 equals 3 pi on 6, which is pi on 2. So 1 over pi on 2 times the integral of, actually we'll integrate it straight away. What is the integral of 2 sine 2x minus 1? Okay, we've got some answers coming in. Cool. So we had some answers that said negative 2 cos of 2x. But that's a very good guess, but it's actually incorrect. And the reason it's incorrect is because of that 2. So because of that 2, we would have to have we'd have to use reverse chain rule, which means we're dividing by the derivative of the inside. So we have to divide this by 2. And the way that we get negative cos is just using this unit circle again. So we go anti-clockwise to negative cos. Cool. And then the 1 becomes minus x. And we have pi on 6 and negative pi on 3. And 1 divided by pi on 2. We do state change flip. So 1 on 1 stays the same. Change the divide to a multiply. We flip the last one, so 2 on pi. So we get 2 over pi. And then we get, so negative cos of 2 pi on 6 minus pi on 6. We'll do a big bracket and little bracket minus negative cos of negative 2 pi on 3 minus pi on 3. All right, so that's 2 on pi times, let me just clear this out a little bit. Negative cos of 2 pi on 6, which is pi on 3. So cos of pi on 3 is a half. So you get negative half minus pi on 6 minus cos of negative 2 pi on 3. So that's going to be in this quadrant. So we'll have a negative number, and that'll be negative half. So negative times negative a half plus pi on 3. And that's 2 on pi times negative a half. Expand that out. So that'll be plus a half. That'll be plus a half minus a half again. So minus a half. Let me clear this out. Sorry, it's very messy, guys. And we have negative pi on 6 minus pi on 3. So we get 2 on pi, brackets, minus 1. Then negative pi on 6 minus pi on 3 will be minus pi on 2. So we get negative 2 on pi minus 1. So 2 on pi times negative pi on 2 will be negative 1. Okay. So that's our average value. So that's a lot of working for 3 marks, but could be worth the 3 marks. Depends on what situation you're in on the exam. Okay. It is 1:02, so it is lunchtime. We'll be back at 2 o'clock. I think we may have a Q&A slide next. Let me just check. Yes, we have a Q&A slide. So during lunchtime, put in your questions. And just before we start, so I'll probably start answering questions at like 1:50, 1:55. Actually, let's say I'll start answering questions at 1:55. And then we'll come back and restart at 2 o'clock. All right, thanks everyone. Oh yeah, I forgot to say you can stay on the link and just come back at 2 o'clock. All right, I think I'll answer some questions just before we get started. What were your subjects in year 12? I did methods, spec, English, chem, my school made us do religion, and what else did I do? And bio. Can you explain average value 1 over b minus a again? Okay, we'll quickly do that. So basically, the b minus a is the distance along the x-axis. So that's like your horizontal length for your rectangle. And the integral from a to b is the area. So what you're doing is you're taking the area under that graph and then dividing it by the x distance, or the length of the rectangle. And then if we do area divided by length of a rectangle, we'll get the width. So that's the height of the rectangle. Cool. Hope that answers your question. What study score did you get for methods? I got a raw 64, I think. It's a while ago. Sorry, not 64, 46. That would be crazy if I got a 64. What are you doing in uni? I'm doing medicine in uni. I'm in my 4th year of medicine. Yeah. Do we have anyone who is interested in doing medicine? Yep, we got a few people interested in medicine. It's a great course. I can answer a few questions about it if you have any at the end. What would be the best way to spend those last few weeks? Oh, we did that one. I think that's it. We had another question, why medicine? So I think I was really, really interested in kind of biology and like human biology in particular. And I knew I wanted to go into a career where it's like really cliche, but like a career where I'm helping people, where I'm kind of like talking to people every day, helping them deal with medical conditions which are like out of their control. And I really like how in medicine it's kind of a team-based career. So you work with your team. You've got people who are like more junior to you. You've got people who are more senior, and you kind of are teaching people every day. You're teaching people who are more junior to you. You're learning from people who are more senior to you. I really like that aspect of medicine. What do you think is the best way to prepare for interviews? There's a lot of like practice interview scenarios online. I found in like forums and stuff. The best way I think would just be to look over those and just think about what you would talk about, and maybe discuss it with friends as well. Just like think about what you would, how you would answer those questions. I think is the best way to prepare. Cool. There was another question, what school did you go to? I won't answer that because I don't want to dox myself, but yeah. All right. I appreciate your interest though. Let me just find my pen. Okay, let's get started. Okay, wait, there were more Q&As in the Zoom Q&A. How many practice exams did you do for methods? I don't remember, maybe like 20 all up, but that's because I started a little bit earlier. I would recommend doing at least 10, because with each practice exam, you'll get so much better, and you'll really surprise yourself how much better you get doing each practice, and that's the only way to get better, only way to learn what it is you need to work on, and then you can go and work on those things. And we'll leave the rest of those questions to later. So we'll just watch a quick video.
Hi, my name is Josh, and I'll be taking you through the Skyline Hatch Chemistry Revision Series. We'll be going through everything that's covered in chemistry, from fuels to fuel cells to electrolysis, equilibrium, organic chemistry, and food chem.
All right, so that's Josh. He's also in medicine. He's one of my friends. He's taking the chemistry revision series. Oops. Make sure you tune in for that. Oops. Okay, so probability. What is a random variable? So with probability, we'll be talking about random variables. They're just numbers. A variable is something that we don't know. It's a number we don't know. Could be anything from a given set of numbers. So for example, if we let x be the number that we roll on a dice, we could have x equals 1, x equals 2, etc. PR of x equals 1 means what is the probability that we roll a 1? PR x is odd means what is the probability that we roll an odd number? So the way that we do probability questions is we still do that. What do we still use that structure of what do we want? What do we have? How do we do it? But the first step is to determine what type of probability we're using. And that's the most important step. And I'll teach you how to identify that. So there's 4 types of probability: discrete, binomial, continuous, and normal. So technically binomial is like a subtype of discrete and normal is a subtype of continuous. But for the purposes of this revision series, we'll just say binomial. We'll talk about binomial as if it's different. So continuous variables are any variable within a certain range. So they'll either have these square brackets or they'll have round brackets. So the length of a pencil could be between 6 and 12 centimeters. Discrete variables are when there's only a countable number of values and nothing in between. So they'll have the curly brackets. So you can have 1, 2, or 3 children. Can't have 1.26 children, something like that. So discrete variables. These are some formulas that you may remember from year 11. I'll give you a second to screenshot that if you want, and then we'll move on. Okay, conditional probability. These, you can identify these because they'll say, what is the probability of A given B? Or it'll say, what is, if B occurs, then what is the probability of A? And we use this formula, probability of A line B. So that's the probability of A given B equals the intersection over the probability of B. So mutually exclusive versus independent. Everyone always struggles with this. I struggled with this. But the way that I remembered it is because mutually exclusive means that A and B exclude each other. So they're like very separate from each other. And so that means that the intersection is 0. So the probability of intersection equals 0. Independent means that A does not affect B and B does not affect A. That doesn't necessarily mean that they don't intersect. It just means that if you have A, the probability of getting B doesn't change. So if it's independent, the probability of A given B, the probability of A intersection B equals the probability of A times the probability of B. Some important tools. So tree diagram is used a lot, and the two-way table or the Carnot map, we'll be using both of those today. All right, so we'll give you a minute or two to have a go at this question. And think about the tools that we might use for this one. All right, let's have a go at the first question. So which tool do you reckon that we might use for this one? Out of, say, the tree diagram or the Carnot map or the two-way table? Yeah, I reckon tree diagram is the way to go. So we've got a coin that's tossed 3 times. It's biased as well, which means it's not just 50-50. And we're trying to find the probability of 3 heads happening from 3 tosses. So you can have a head or not a head, head, not heads, heads, 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 not heads. All right. Cool. Just making sure that's all right. Yep. So the probability of 3 heads from 3 tosses would mean that we go about along this path. So 1, 2, 3 heads. 1, 2, 3. And since the probability of each of these happening is P, we times P times P times P equals P cubed. All right, next question. 2 heads and a tail from 3 tosses. So what we need to do is identify which of the options on our tree diagram that is. So 2 heads and a tail, it means 2 H's and a not H. So it could be this one, heads, heads, not heads. Could be this one, heads, not heads, and heads. And it could be this one, heads, not heads, heads, and heads. So the probability of H, H, not H would be P times 1 minus P, which is the probability of not getting the heads. Then we notice that since it's the same probability each time, each of these will have the same probability. So we just times it by 3. So we get 3p squared times 1 minus p. If the probability of obtaining 3 heads equals the probability of obtaining 2 heads and a tail, find p. So what we need to do is we make this equal to this. So p cubed equals p squared times 1 minus p. So one tempting thing to do would be divide by p squared. But the reason we don't do that is because that removes one of our solutions. Because if we divide by p squared, we're losing p's. Therefore, we won't find in the end that p equals 0. So what we do instead is we bring everything to one side, like this. Then we factorize out the p squared instead of dividing it. And then we can use null factor law. So p squared equals 0, p equals 0. P minus 1 plus p equals 0. 2p equals 1, p equals, oh, sorry, hang on, did I do something wrong? I think I did something wrong. Oh, yeah. Three, so this would be p squared times p minus p squared times p minus bracket 1 minus p equals 0. Can't figure out what I did wrong. I've done this a million times by myself, but of course, when I'm in front of 80 people, I can't do it. Oh, it's because of the 3. Yeah, that's right. That's right. Cool. No, sorry, not in front of that one. So take the, sorry. Take the p squared out, we get p minus 3 times 1 minus p equals 0, p equals 0. and P equals 3 minus 3P. 4P equals 3, P equals 3 on 4. Yay, I did it. All right, cool. Let's have a go at this question. All right, for events A and B from a sample space, probability of A given B equals 3 on 4, and the probability of B equals 1 on 3. All right, so I've copied in your formulas here. So you just have to choose the right one and then use that formula to find the intersection. So I'll give you a minute for that. So we had a question, could you use the binomial formula for these questions? So that for the previous question, yes, you can. And that's because the probability is independent. So the probability of getting ahead is not changing. Okay, so the probability of the intersection, the way that we get that is by using this formula. So the probability of A given B is 3 on 4, and that's equal to the probability of the intersection over the probability of B. So probability of intersection equals 3 on 4 times probability of B, which is 1/3. Cancel the 3's, we get 1 on 4. All right, have we go to the next question. And think about whether you'd use any of our tools. All right, so can anyone tell me what tool they might use for this one? Yeah. The table, I think, would be a good idea. The two-way table or the Carnot map. So we have one down here. We've got A dash, B dash. And we'll start filling things in. So we know B is 1/3. We have A intersection B, which is 1/4. And so A dash intersection B will be 1/3 minus 1/4 because we have to add these two squares to get the last square in the row. So 1/3 is 4 on 12. 1/4 is 3 on 12. So we have 1 on 12. Could you also just use a Venn diagram? Yes, you can. Venn diagram works as well. If events A and B are independent, calculate probability of A union B. All right. So if events A and B are independent, the important thing about this is that we can't assume they're independent unless the question tells us they're independent. So now that it has told us they're independent, we're allowed to use this independent formula. So we know that the intersection is 1 on 4, and that's going to be equal to the probability of A times the probability of B, which is 1 on 3. So we have probability of A equals 3 on 4. Let me just clear out some of this. All right. Now we're going to use this addition formula. So probability of the intersection, or we'll say probability of union, is equal to probability of A plus the probability of B minus the probability of the intersection. And the way that we got that is by using the addition formula and then swapping the intersection and the union by minusing the intersection and then adding the union. So what we do now is we do probability of A, which is 3 on 4, plus the probability of B, which is 1 on 3, minus the probability of the intersection, which is 1 on 4. And so we have 2 on 4 plus 1 on 3, which is 6 on 12 plus 4 on 12, which is 10 on 12, which is 5 on 6. Okay, that one was a little bit harder. All right. Pop quiz. All right. Ooh, bit of a spread for this one. The answer is B. It's a classic Fleetwood Mac song. Dreams is on Rumors. Tusk is another Fleetwood Mac song. The Winner Takes It All is ABBA. And How Can You Mend a Broken Heart, I think might be ABBA as well. I don't know. Or it might be Fleetwood Mac. Cool. Okay, probability tables. So 2 rules for probability tables. These will help you when you have like algebra type questions where one of these is P or something like that, and you have to find P. So we need to know that all probabilities add to 1. So 0.2 plus 0.3 plus 0.4 plus 0.1 equals 1. And all individual probabilities are between 0 and 1. So each of these probabilities have to be positive and have to be less than 1. The mean and variance. Now, I know this formula looks crazy, but I'll show you how to use it. And then you don't actually have to remember the formula, you just need to remember how to do it. So the mean is the long run average of a specific variable. And it's the sum. So this big sigma symbol means the sum of x times the probability. And you do x times the probability plus x times the probability, and you keep going along the table like that. The variance is e of x squared minus e of x all squared. So e of x is the mean. So if you've already calculated the mean, you can put that in here. E of x squared is, instead of doing x times the probability, you do x squared times the probability, and then you add them up like that. And standard deviation is the square root of the variance. So I'll show you how to do that in this question. So e of x will be 0 times a quarter plus 1 times 9 on 20 plus 2 times 1 on 10 plus 3 times 1 on 20 plus 6 times 3 on 20. And I put this on the calculator. So this could be an exam 1 question. And you would have they would give you a few marks for this because it is a lot of working. But since I've already put it on the calculator for myself, I'll just scroll up. So I got 29 on 25. Okay, now e of x squared. So remember I said that instead of doing x times the probability, we do x squared times the probability. So that'll be 0 squared times a quarter plus 1 squared times 9 on 20 plus 2 squared times 1 on 10 plus 3 squared times 1 on 20 plus 6 squared times 3 on 20. All right. One common mistake is people might square the probability instead of the x value, but you just have to remember that x is being squared here, not the probability. All right. Just type it into the calculator. And we get 67 on 10. Now the variance will be equal to e of x squared minus e of x all squared. So e of x squared we've already found is 67 on 10. And e of x is 29 on 25. And you square that. Oh, actually, sorry. What did I do differently? Oh, sorry, not 29, 25. I did them wrong on the calculator. That's 17 on 10. And this is 17 on 10 squared. And you get 381 on 100. So you'd have to do variance questions like that. If it was really, really terrible numbers in the end, that would probably be exam 1. But other than that, that's definitely possible for exam 2. Sorry, other way around. If it was terrible, it'd be exam 2. Otherwise, it's possible it could be exam 1. So how do we know we're using binomial probability? So this is what I was saying at the start, how it's really important to know what type of probability you're dealing with. So in binomial probability, you have 2 possible outcomes. So heads or tails, sheep or not a sheep, tagged or not tagged. The probability of each outcome does not change. So if you get a heads the first time, if the probability doesn't change when you do the second toss, then it is independent. That means we can use probability. If you're doing like picking cards out of a deck and then you put the card back before you pick the next one with replacement, then it's independent as well and you can use binomial. So these are the formulas that you'll have to use. I'm pretty sure these are in your formula sheet. And I'll be going through how to use them. So defining a binomial. The first thing you want to do is define the binomial using a certain letter. That will be your variable. So if we're tossing a coin 5 times, we have n equals 5, which is the number of trials. And the probability, since it's a fair coin, the probability is 0.5. So we'll define it as x is the number of heads tossed, and then we'll say x is a binomial variable where n is 5 and p is 0.5. That's how you define it, and you actually get marks for defining it properly. NCR. Okay, so this is on your calculator. As you can, I think you can literally type in NCR on your calculator. So NCR, and then you type in the N value and you type in the R value. So this is the formula you would use for that. And the factorial, which is the exclamation mark, is just what you get when you take the number, then you multiply by counting down. So 5 factorial is 5 times 4 times 3 times 2 times 1. So we'll have a go at evaluating this. So this is the same as 5C3. And so if we use our formula, we get 5 factorial over 3 factorial times 5 minus 3 factorial. So 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 and 2 times 1. So we have a question, is R the probability? No, R is not the probability. I'll show you what R is in a few slides. So what we can do here is we can cancel the 3 times 2 times 1. And we're left with 5 times 4 over 2. And we can cancel that. And we get 10. So this is not a probability. NCR is not a probability. And we shouldn't say 5 over 3 because technically it's not a fraction either. It's just a number. Okay, so for this question, all I'm asking is, can we use binomial or can we not use binomial? What do you guys reckon? And remember, there has to be 2 outcomes and the probability cannot change between trials. Good. Lots of people saying cannot use binomial. Why not? Because the probability is changing. Well done. You guys are amazing. All right. Can we use probability for this one? Can we use binomial, sorry? Yep. So people are saying yes. And we can use binomial because the sheep is then returned to the paddock, meaning there is replacement. So therefore it's independent. All right, let's have a go at doing this question and I'll do it with you. So a paddock contains 10 tagged sheep, 20 untagged sheep. 4 times each day, 1 sheep is selected at random from the paddock, placed in an observation area and studied, and then returned to the paddock. So this is something I would definitely highlight. 10 tagged sheep, 20 tagged sheep, kind of important, not amazingly important. 4 times each day, kind of important. What is the probability that the number of tagged sheep selected on a given day is 0? So first thing we got to do is define our variable. So we've decided, okay, this is binomial. We need to define our variable first. So let's say X is number of tagged sheep. Then we'll say X is a binomial variable where N is the 30, the total number of sheep, and P is 1 on 3. Sorry, not 30, should be 4 because there are 4 sheep chosen in the day. So that's a really important thing. Lucky I highlighted that. Cool. What is the probability that the number of tagged sheep is 0? So what we do is we say PRX equals 0. And we use our formula. So N is 4. X is going to be whatever this value is, 0. P is 1/3 to the power of 0 times 2/3 to the power of 3. And so we get 4C0 is equal to, sorry, not 3, 4. 4C0 is, we use this formula, so 4 times 3 times 2 times 1 over 0 factorial times n minus x, so that's 4 factorial. So question, why is it 0? Can it not be like 1? So the question's asking for the number of tagged sheep is 0. So we won't be able to use 1. But that might be confusing because you might say, oh, there's a 0 on the bottom here. But actually 0 factorial is 1. That's a really like complicated maths proof that 0 factorial is 1. But if you, for this session, we'll just have to accept that 0 factorial is 1. It is really weird. I understand that. But essentially, then we've got 4 factorial over 4 factorial. So you cancel those and you're just left with 1. So in the end, you have 2 to the 4 over 3 to the 4, which is 16 on 81. What is the probability that at least one tagged sheep on a selected, that you get at least one tagged sheep on a selected given day? So we have probability that X is greater than or equal to 1. So that's at least 1. An important thing to remember is that it's not X is greater than 1, it's X is at least 1, which means it could be equal to 1 as well. Now, a good tip, instead of doing probability of X equals 1 plus probability X equals 2 plus X equals 3 plus X equals 4, you can actually just do 1 minus the probability of X equals 0, because that'll be everything that's greater than 0. So you do 1 minus 16 on 81. So you have 81 on 81 minus 16 on 81, which is 65 on 81. All right. For binomial variables, we use a different formula for the mean. Because we have n and p, it's a lot easier to work out our mean. But remember, this only works if it's binomial. So the mean is n times p. The variance is np times 1 minus p. And the standard deviation is the root of the variance. Now remember, the mean is the long run average and the variance is how spread out the values are. So we'll have a go at this one. This will be on Menti as well. And you can use a calculator for this, by the way. I don't know if I mentioned. Okay. Not as many people got this, and I understand why. It's because this is a really, it is a hard question. And it's hard because you need to do a lot of work just to get 1 mark. And because it's 1 mark, it's only 90 seconds. So this might be one of those questions that you're like, maybe it's not worth the mark. But the way that we do this is really good if like it shows up on exam 1 as well. So it's really good to practice. The way that we do it is we know that E of X equals NP. So NP equals 2 and variance is NP times 1 minus P equals 4 on 3. So since NP equals 2, we can just sub that in for NP over here. So 2 times 1 minus P equals 4 on 3. And 1 minus P equals 2 on 3. And we have P equals 1 on 3. So if we sub that back in, we get n times 1 on 3 equals 2. N on 3 equals 2, n equals 6. Now we need to find probability x equals 1. So that would be 6c1 times probability. So that's 1/3 times 1 to the power of 1 times 2/3 to the power of 5. And a good tip is that anything C1 will be the n value. So 6C1 is 6. So 5C1 will be 5. And AC1 will be A. So now we have 6 times 1/3 times 2/3 on 5. And another tip, just so I don't forget, 5C0 equals 1. And AC0 equals 1 as well. So anything C0 equals 1. And anything C1 will equal whatever the n was. All right, cool. So quick break now and a bit of a Q&A. So I'll go through some of those Q&A questions. Will we have a copy of the annotated slides? I think so, yes. Would we be able to, can we send the slides now? Yeah, cool. I will do that. How do you find the area bounded by the y-axis and a graph? We didn't cover that specifically today, but basically you just want to get the area from x equals 0, which is where the y-axis would be, and then you go as far as you want to the right or to the left to get that specific area. But it's not dependent on whether it's bounded by the y-axis. The bounded by the y-axis just tells you how far along the x-axis you have to go. So you start at x equals 0. Are calculus first principles required for the exam? First principles is annoying to focus on as an example, and I really don't like the estimation. I've never seen first principles on an exam. I think it's technically more year 11, and it's technically on the study design, but it's never been on a year 12 exam that I've seen. What would be the best way to spend those last, oh, we already answered that. Cool, okay. We're going really well for time. So we'll give you a 10-minute break, come back at 2:50. All right, we'll do a quick Q&A while people come back. How do you recommend using reading time? So during my reading time, how I felt that like I used my time when I practiced, I felt this was the best for me. It was reading through multi-choice, trying to do some of the easy questions in my head and just remembering what the answer was. Some people go to short answer and read through the short answer, decide what are the easy questions there. So you can do those questions first. It's really up to you. An, what did you do, if you don't mind me asking, during your reading time?
Yeah, I would just like glimpse through the multiple choice because it won't add up that much compared to your other sections. Yeah. So like usually I would go for the harder stuff first and then come back to the multiple choice. Just in case if I run out of time.
Cool. And the other thing with multi-choice is if you leave it towards the end, you can just guess as well. And you have a 1 in 5 chance. How do you organize your bound reference and how do you make it as useful as possible? So the bound reference is so important. You want to organize it so that you know where everything is, so you can access it when you need to during the exam. So if you want to have just like color code the top right corner, so you can flick through it, find the color that you're looking for. So like graphs, algebra, differentiation, etc. And then once you've got it organized, you want to do your like notes, then practice examples. And the examples are probably even more important than the notes themselves. So that's how I would organize my bound reference. And every time you come across a difficult question in the exam, chuck it in your bound reference. So if something similar pops up, you'll be able to know how to do it. Are we able to use techniques from specialists in the methods exam, for example, compound double angle formulae to simplify an expression? It doesn't, that example in particular doesn't come up in methods, so you wouldn't really need to, but I think you technically can use special techniques, but you just have to make sure you get the right answer. But other than that, I think you are allowed to use whatever technique you want, as long as there is some working, so you can get the mark for working. I've always struggled with domain and ranges of composite functions. How do you do this? So basically, I just like consider it like the machine. So the inside function first and then the outside function. The range of the inside, so the y value of the inside, becomes the x value of the outside, because it goes through the first function first, then comes out, and then it goes into the outside function and comes out again. I can go through it again at the end if we have time. What would be the best way to spend? Oh yeah, we're back to the start. Okay, awesome. Let's continue. I would watch a quick video from Skyline.
Hey, my name is Bridget and I'll be taking the economics exam revision session. So I'm really excited to walk through all of those key pieces of content included in the study design dot points for economics, and also some fantastic tips on how to maximize your marks when it comes up to the exam so that you can do as best as you possibly can in economics this year. My study tip for the end of the year exams would be to introduce some kind of active recall into your studying. You can probably look this up on Google, but it is a really proven technique to use. So you might want to incorporate flashcards or questions that you write for yourself that really cause you to recall that knowledge and not necessarily just recognize it like you would if you were maybe reading a textbook or reading over some notes.
Cool. Thanks to Bridget for that. And we'll just watch one more video.
Come to the exam revision series in partnership with UBS. For our science sessions, we're offering exam revision in chemistry and psychology. Over 3 hours, we will cover the critical content of VCE chemistry, with specific focus on maximising scores through specific strategies to tackle both multiple choice and extended response questions. In our psychology session, we'll cover the nervous system functioning and stress as an example of a psychobiological process, neural basis of learning and memory, as well as an explanation of the process of memory and the debate behind its reliability. Models to explain learning, consciousness, sleep disturbances and possible treatments, mental health disorders, and phobias. By the end of the session, you will have developed strategies in time management, applied difficult concepts onto difficult and frequently appearing questions, and learn how to avoid the common mistakes. Join us as part of your exam revision by scanning the QR code or visit skyline.org.au to view our full 2022 exam revision schedule.
Cool. All right, continuous variables. So when do we use continuous variables? they'll be defined by a function like this, and that's how they're different to normal variables. So normal variables will be defined a bit differently, and we'll go through that in a bit. So they're defined by a function, and the area between C and D will tell you the probability that you can get between C and D. So it's all about area with continuous. The area under the whole graph must equal 1, and the graph always has to be positive. And this will help you in this question. So let x be a continuous random variable with the following probability density function. Determine the constant k such that f is a valid probability density function. So we'll give you a minute to try and do this one. Give it a shot. All right. Can anyone tell me what their approach to this kind of question would be? Good. Good. So we integrate between 0 and 2, and that will give us the probability of the whole thing. And we know that the probability under the whole graph equals 1. So we go integral from 0 to 2 of x squared plus kx plus 1 equals 1. And we can put that directly on our calculator and solve for k. And we get k equals negative 11 on 6. Good. It's a very common question. Let x be a continuous random variable with probability density function given by this. Sketch the graph of that. So I'll do that with you guys. So we know it's a parabola and it goes from 0 to 1. So let's sub in 1. So f of 1 equals 3 times 1 squared equals 3. So we have 1 comma 3. And our graph looks like this. And since we have 0 from x is greater than 1 and x is less than 0, we need to draw this line like that. Find the probability that 0.25 is less than x less than 0.75 and illustrate this on your graph. What do you reckon you guys might do for this? How do you reckon you'd find that probability? Yep. So we integrate between 0.25 and 0.75, and we integrate 3x squared like that. Cool. And we would illustrate this on the graph like this. where this is 0.25, this is 0.75. Cool. So for continuous variables, the mean is, as always, it's the long run average, and it's given using this. So you integrate the whole thing, except instead of just doing the integral of f of x, you do the integral of x times f of x. Okay. Variance, it's ex squared minus the mean squared, and standard deviation is the square root of variance. The way that you do ex squared, so this is another hard one. So you do the integral from -infinity to infinity. Instead of doing x f of x, you do x squared f of x. So we're pretty much timesing it by whatever's in that bracket. So the way that we do this one, so the weight in W in grams of controllers is modeled by the following probability density function. Determine the mean weight in grams of the controllers. So the way that we do this, we'd say E of W, because W is our variable, not X. E of W is the integral from 290 to 330, so the entire graph. 3 over 640,000 times 330 minus W squared, W minus 290, and then we times it by W so that we get the mean. And if we do that on the calculator, we should get 306. And we'll write grams as well. All right. Just making sure everything's correct. All right, cool. Random variable has the probability density function this. Find the variance of x and hence find the standard deviation of x. How might we go about finding the variance? Can anyone tell me? Integrate 2x times x squared between 1 and 0. Good. Yes. Okay, good. So we can find the mean first, and we can also find e of x squared. So let's find e of x squared first. So e of x squared will be the integral from 0 to 1 of 2x times x squared. So remember, we're timesing it by whatever's in that bracket. Dx. And this will give you half. E of x, it will be 0 to 1 of 2x times whatever's in the bracket, so x dx. This is equal to 2/3. And the variance will be e of x squared. I'm doing this all in the calculator, by the way. You don't have to do this in your head. You may have to if it's really simple on exam 1, but most of the time it'll be exam 2. So it'll be e of x squared, so half minus e of x all squared, like that. And you get 1 on 18. So how would we get the standard deviation? We'd square root it. Very good. You guys are great. Awesome. 1 on square root 18. So that's 1 on 3 root 2. Good. All right, when the domain goes to infinity. So this is one of those difficult questions which is like not really covered that much in the textbook, but it can come up on your exam. So the length of time X minutes between arrival of customers at an ATM is a random variable with probability density function this. Find the probability that more than 8 minutes elapses between successive customers. So the way that we'd write this is probability X is greater than 8. And then you have to do integral from 8 to infinity of 1/5 e to the negative x on 5. So one way of doing this is to integrate that function first. So we'll just quickly do that. So we have negative e to the power of negative x on 5. And then we can sub in infinity, but we're not actually subbing it in. In our heads, we're actually thinking, what's e to the power of, so we'll do it first. So negative e to the power of negative infinity on 5. We're not subbing it in, but we're actually saying, what's e to the power of negative infinity? So that'll be e to the power of negative infinity is 1 over e to the power of infinity. And e to the power of infinity is a massive number. So 1 over a massive number can be approximated to 0. So we can say that this is 0. Then we minus negative e to the power of negative 8 on 5. And we get 0 plus e to the negative 8 on 5. The second way of doing this is to say that probability that x is greater than 8 is the same as probability that, or 1 minus the probability that x is less than 8. So 1 minus probabilities that we're going from 0 to 8 of 1/5 e to the negative x on 5. Then you can work that out as well. Would this be an exam 1 question? Yeah, I think this is a fair exam 1 question. Might be 2 marks. But yeah, definitely possible. The median. The median is the middle of the distribution. So it means the probability of getting lower than m is the same as the probability of getting higher than m. And because those two probabilities are exactly the same, they must each be half or 0.5. So probability that x is less than m equals 0.5, and the probability that x is greater than m is 0.5. That's what the median means. All right, pop quiz. What country are these superstars from? All right, well done. Most people got Sweden. Switzerland was a close second. But yeah, ABBA is from Sweden. Normal random variables. When do we use normal random variables? Okay, so we use normal random variables when the question says blah is normally distributed. So it'll literally tell you when to use it. And we define it like binomials. We define it with x squiggly line n instead of by bi, then the mean and the standard deviation squared, which is the variance. Special properties of all normals. So they are always symmetrical about the mean. So they're symmetrical if you flip it in the mean. The area under the curve tells us the probability, same with continuous. And certain areas always have the same probability. So what I mean by that is that the probability of getting more than the mean is always 0.5. So the mean is the median in this case. The probability of getting within 1 standard deviation is 68%. Probability of getting within 2 standard deviations of the mean is 95, and the probability of getting within 3 standard deviations is 99.7. Now, people from further might know that already. Cool. So this is just another representation of that. So 1 standard deviation to the left and to the right will give you 68, and this is called the 68, 95, 99.7 rule. The standard normal distribution. So it feels like mathematicians just making stuff up now, but the standard normal distribution is actually a really important distribution because it's used, it can be used for any equation, and you can always convert to the standard normal distribution. So it's a special distribution with a mean of 0 and a standard deviation of 1. And so it's given by the variable z. So z always means the special distribution, which is the standard normal, as a mean of 0 and a standard deviation of 1. And we can convert any other variable to z. And we do that using this formula. Z equals x minus mu over sigma, where mu is the mean, sigma is the standard deviation. That's called standardizing. Okay. Does anyone know how we would do this first question? Finding the probability that z is between 0 and 1. And we would not use the calculator for this one. Okay, we're getting a mixture of answers here. So the way that we do it is we use the 68, 95, 99.7 rule. For the z distribution, the mean is 0 and the standard deviation is 1. So we can write these in. And for the probability that z is between 0 and 1, this will be this section here. And since we know that from -1 to 1 is 68%, we can say from 0 to 1 will be 34%. And if we want to write that as a probability, we can say that is 0.34. So how do we find the probability that z is greater than 1? Okay, so we're getting a mixture of answers and a mixture of methods as well. So for probability z is greater than 1, every time we're doing these kinds of probabilities, we have to draw a graph. So we have this graph and we say, okay, what are we trying to find? We're trying to find when the probability is greater than 1. So what we need to do is, let me rub out this stuff first. We'll keep that 34%. Okay. We know that the probability that z is greater than 0 is 50%. And the probability that z is between 0 and 1 is 34%. Therefore, the probability that z is greater than 1 will be 50 minus 34, which is 16%, equals 0.16. Good. And there's lots of different ways of doing it. You could say 1 minus 68% and then divide everything by 2. and that'll give you just one of these tails. There's lots of different ways of doing it. You can find out which way works best for you. All right, let X be a normally distributed random variable with a mean of 6 and a variance of 4. Let Z be a random variable with the standard normal distribution. So again, this is where we have to remember that Z is the normal variable with a mean of 0 and a standard deviation of 1. Find the probability that X is greater than 6. How would we do this? Or which, I've kind of given the answer, but what on the calculator would we be, what function on the calculator would we be looking for? Yep, so we've got menu 552, that's on the TI Inspire. Menu 552, normal CDF. You can also get the normal CDF on the Casio. What would we find, what would be the lower bound? 6, upper bound, infinity. The mean is 6, and what would be the sigma? 2, good. So you might be tempted to put in 4, but sigma is, remember 4 is sigma squared. So sigma is standard deviation, which is 2. So if we put all those in, let's see what we get. So 6, infinity, 6 and 2, and we get 0.5. So this is exam 1, but I've shown you how to do it on exam 2, just as like for when you do harder questions. How would we do this on exam 1? Good, because the mean is 6, and we're trying to find the probability that we're getting greater than 6, the probability would just be 0.5 because that's half of the distribution. Well done. All right, this one will be on Menti. So there's a multi-choice. The continuous random variable X has a normal distribution with a mean 14 and a standard deviation of 2. If the random variable Z has some standard normal distribution, then the probability that X is greater than 17 is equal to, this one's a bit harder. All right. So the answer was D. So that one was a little bit harder. Not everyone answered it. That's okay. So the way that we do this is because our x value is defined as 14 and 2, we have to convert that to z. So we want to find the probability that x is greater than 17. And to standardize it, we have to use this formula. So convert to z. So that's probability that z is greater than 17 minus mu, which is 14 over 2. So probability that z is greater than 3 on 2, which is the probability that z is greater than 1.5. And then the problem is none of the answers are z is greater than 1.5. So we need to find something that's equivalent to that. And because the standard normal is symmetrical about 0, which means it has a mean of 0, if something is greater than 1.5, that probability is the same as being less than negative 1.5. That's why the answer is D. All right. Inverse normal. So inverse normal is the opposite of what we've been doing. So we've been doing, when we know the x value, we're trying to find the area, which is the probability. Inverse normal is when we have the probability and we're trying to find the x value. So you can find inverse normal on your calculator. And basically, we want to first have the area and then put in the mean and the standard deviation. And then the calculator will tell us the x value. So have a go at this question. This one will be on Menti as well. Okay, so the answer was D, which most people got. Very well done. The reason it was D is because, we'll go through the whole thing. So we have a normal distribution, the mean of 30, and a standard deviation of 5. We're trying to find the value of A, where the probability of getting greater than A is 0.2. So we'll put A over here, and this probability is 0.2. Now, one common thing that people might do is they'll say, okay, area is 0.2, mean is 30, standard deviation is 5. But if you put this on your TI Inspire, that the calculator actually assumes that you're coming from the left. So they'll actually take this area, the left tail, and they'll say, oh, they'll give you this value X. not the value 8, which is the one you want. So what area would you have to put if the graph is coming from the left? 0.8, good. So we actually have to put in 0.8 so that the graph knows that we're going all the way to the right side of the graph. And then we'll get A equals 34.21. All right, next pop quiz. What movie theme song does Dustin sing to Susie at the end of its season 3 in Stranger Things? This is one of the best scenes in my opinion. Good. Never Ending Story was the answer. All right, statistics. Once we go through statistics, we'll be going through some hard questions from all the areas of study. So strap in for that. All right, so statistics. Population proportion. This is the proportion of a thing out of everyone in the population. So this is the proportion of students in Australia that do methods. The sample proportion is when we take a sample out of people in Australia and we calculate how many people do methods. So it's a proportion of a thing out of only the people in that smaller sample. So whereas the population is Australia, the sample is a school in Australia. The variable for the sample proportion is given as p hat equals x over n. So x is the number of people who do methods, and n is the number of people who do methods in that class. It's the number of people in the class. So in a certain school, 35% of the students travel on the school bus. A group of 100 students were selected in a random sample, and 42 of them travel on the school bus. In this example, what is the population? Not what is the population proportion, but what is the population? What do you reckon? Okay, so a lot of people are saying 100, but the population is the students in the school. So a proportion will be a number, the sample size will be a number, but the population is a group. It's not necessarily a number. The population that we're taking from is the students in the school. 100 is the size of the sample. So the population is like everyone, 100 is the small sample that we're taking from the whole school. The population is students at the school. What is the value of the population proportion? What do you reckon? .35, very good. So since it's a proportion, that is a number, and that's it's a proportion of people in the school who travel by bus. What is the value of the sample proportion? 0.42, very good. So that's the proportion in the small sample. So the 0.35 is the proportion in the whole school. The 0.42 is this proportion in the 100 students that were in the sample. All right. Important definitions. So confidence interval. This is used after we get a sample proportion and we have to guess the population proportion. So if we go back to this question and we only knew the sample, so we didn't know how many students in the whole school were going by bus, but we did take a sample and we found that 42 out of the 100 were going by bus. That would be our sample proportion. And the 95% confidence interval is like an interval that is guessing where the actual number might be. So 42% might be in the middle, and then you might say, oh, could be, it would be greater than this number and less than this number, but it's a complete guess about what the population proportion is. And by guess, I don't mean you just guess the number. You actually have to use a formula to get an accurate guess. And this is the formula. So p hat minus 1.96 times the square root of p hat times 1 minus p hat over n. And then you do the same, except it's plus. The margin of error tells you how wide your guess is. So how accurate, if it's more accurate, it means it's a smaller width. And so the margin of error is smaller. If it's less accurate, that means it's a larger width and the margin of error is bigger. So the margin of error is just this end value. So p hat plus whatever, that is the margin of error. A quality control engineer in a factory needs to estimate the proportion of bags of potato chips packed by a certain machine that are underweight. That's a lot of words. The engineer takes a random sample of 100 bags and finds that 8 of them are underweight. Find a point estimate for P, the proportion of bags packed by the machine that are underweight. So the point estimate is the sample proportion. What do you guys reckon? Good, 0.08. So the way that we got that is we got the number of bags that were underweight and we put that over the size of the sample. So 8 over 100 equals 0.08. Calculate a 95% confidence interval for P. So this would definitely be a calculator question. If this was an exam 1 question, instead of 1.96, they'll tell you to use 2. But we'll do this by calculator. So p hat equals 0.08. So 0.08 minus 1.96 times 0.08 times 1 minus 0.08 over n, which is 100. And then you do the same on this side. Just copy paste. Does not do that. That's fine. 0.08 plus 1.96 times 0.08 times 1 minus 0.08 over 100. All right. Now you can put that in the calculator. But there's another tip. You can actually get the confidence interval straight away on your calculator without having to type in the whole formula. So on the TI Inspire, you can go menu 6, 6, and then you go 1 prop Z interval. And I don't have a Casio, and I tried looking up how to find the 1 prop Z interval on the Casio, but I couldn't figure it out. You can probably ask one of your teachers if you have a Casio. But this is what it looks like on the TI. Oh, I don't know if that'll... I don't know. I don't think that'll work. But you go to 1 prop Z interval and you get the number of successes. I think the next slide might have it. No, it doesn't. So you can type in the number of successes, which is X. And the number of successes in this is 8. You can type in N, which is 100. Then you could type in the confidence level, which is 95%, so 0.95. And then once you do that, it'll give you the 95% confidence interval. And so we get 0.027, comma, 0.133. Cool. So this is a common multi-choice question, confidence intervals. All right, next multi-choice. This one is easier than you might think, but it's not an easy question. All right, head to Menti for this one. All right. Oh, did I? Oh, sorry. I think I might have put the timer too low. That's my bad. It's question, it was answer A. So the way that we get this is you might think, oh, I need to sub it into the formula, work out n and p hat, all that stuff. But actually, we are trying to find a sample proportion, which is p hat. And p hat is the middle of those two, of the lower limit and the upper limit. It's the middle of them. So this is p hat minus something. This is p hat plus the exact same something. So if we add them together, 0.039 plus 0.121 divided by 2, we will get, so let's just do that quickly, 3.039 plus 0.121 divided by 2, 0.808. Cool. All right, let's do some difficult questions from the entire course. All right, so a little bit more difficult, not insanely difficult. Let's find some. Are there any areas of study that you guys want to practice more? Okay, we're getting a mix of everything. Let's do a bit of probability. Let's try question 10. I'll give you guys a minute and a half to have a go at this question. This one's not on Menti. This one will just be, you'll just have to do it by yourself without Mentimeter. Okay. So we're getting a few different answers for this one, but let's go through it. So this one's a little bit harder. Which tool did you guys use for this one, if any? Yeah, Kano map, I think, is a good idea. So go A dash, B dash. A intersection B is P. A dash intersection B is P minus 1 on 8. And A intersection B dash is 3P on 5. Now, our plan of attack here is to try and find, we know that the intersection is P, and we know it says it's independent, which means that the probability of A times the probability of B will equal our intersection. So the plan of attack is to create some kind of equation, which we can then solve to find P. And we know that this is equal to P. So what we need to find is probability of A times the probability of B. So probability of A is P plus 3/5 of P, which will be 8P on 5. And the probability of B will be P plus P minus 1/8. So we're just adding across. We get 2P minus 1/8. And so probability of A is 8P on 5 times 2P minus 1 on 8 equals P. And then chuck this on the calculator. 8 times P on 5 times bracket 2P minus 1 on 8 equals P. And we get P equals 0 or P equals 3 on 8. And then we have to try and decide which one it is. So for people who said P equals 3 on 8, why are we discounting 0? Okay, so someone said that implies they're mutually exclusive, but something can be mutually exclusive and independent at the same time. So it could be mutually exclusive. Okay, probability can't be negative. Good. So here we would have 0 minus 1 on 8, and that would give a negative probability. Therefore, we can't have 0. Therefore, the answer is 3 on 8. Good. So that one's a little bit harder. How'd you guys feel about that one? Not too bad, not too bad. All right. Let's pick a calculus one. Let's do this one. Whoops. For the function this, the subset of r for which the gradient of f is negative is this. Okay. What would be our plan of attack? Okay, so we're getting a mix of differentiate first and sketch the graph first. I'm actually more partial to sketching it first and then differentiating, because I find that graphing it first helps you frame your mind. You're like, okay, I know what I'm dealing with, and then you can sketch it if you need to. So let's graph this first. We know that this is a cubic in x-intercept form. So the x-intercepts are -5 and 1. And what does this squared above the x plus 5 tell us? Turning point, good. So it's going to bounce at that point. And is this a positive or a negative cubic? Positive, good. So we can graph it like this. So it bounces at -5, then goes up. All right. So now that we've graphed it, we look back, we're trying to find the gradient of f, trying to find where the gradient of f is negative. So it'll be something less than 5, or it'll be something along here, less than -5, sorry. Gradient of f is negative. So what do we reckon our next step would be? Differentiate it. Yep. So we can differentiate it. And to differentiate it, we'll get x plus 5 squared times x minus 1. Sorry. And we get 3 times x plus 1 times x minus 5. X plus 5, sorry. And we're trying to find where that is negative. So literally what we can put on the calculator, we put that equation in and we say less than 0. And that should give us our answer. Let's see. Yep. And it says x is between -5 and -1. Cool. All right. Let's have a go at this question, 18. So the equation, this has only one solution for x when what? How would we do this one? Okay, so we have one answer, discriminant. So discriminant doesn't work for cubics, but that's a very good guess. So discriminant only works for quadratics. How else might we do this? Trial and error. That's possible. Sketch the graph. Good. I do like sketching graphs. All right, let's sketch it. And by sketch it, I mean get the computer to sketch it, because this is an exam too, so we can chuck it straight on the calculator. So when I'm on my computer, I like to use Desmos. But you guys can just use your calculators for this. Minus 9x squared plus 15x plus w. So on your calculators, you should be able to add a slider for w. And on your calculators, you'll be able to change w. So let's change this to 20. Yeah, let's make it 30. And then we'll go down to -10. And then we'll see what happens as we change w. So as we go up, we're only looking for one solution. So we're looking at how many times it crosses the x-axis. When w equals 25, it crosses the x-axis twice. And when it's greater than 25, it crosses once. Then let's go to the left. When w equals -7, it crosses twice. When it's less than -7, it crosses once. Therefore, the answer will be, what do you reckon? Good, we got one answer for D. Excellent. So we know that w less than -7, it's only crossing once, and w greater than 25, it's only crossing once. That's how we do that question. The alternative would be to graph this without w, graph -w, and I'll show you why we're doing -w, because we can say that this is x cubed minus 9x squared plus 15x equals negative w. And then we're finding where those two graphs intersect. So if we graph that for negative w, and then we'll say w is between 7 and negative 25, because we're just swapping them. Oh, I don't know why it's not graphing w. Either way, that'll work on your calculator. I don't know why Desmos isn't working now. That's fine. Yep, cool. Okay. What we'll do now is we'll do some Q&A for the last 9 minutes. So we'll go to the Q&A slide. We'll answer some of your questions. Okay. With the composite functions, what I'm confused about is what the domain and range would be if the extreme values of the inner function aren't defined in the outer function. Okay, let me understand this question. What I'm confused about is what the domain and range of the outer function would be if the extreme values of the inner function aren't defined in the outer function. Oh, so you're saying the range of the inner doesn't fit inside the domain of the outer. If that happens, the whole function is undefined. So there is no domain and range. So let's go back here. So if the range that's coming out of F doesn't fit inside the domain of G, then the whole graph doesn't exist because the whole graph is undefined. Therefore, the domain and range of the outer is not relevant because it doesn't exist. I think that might be what you're asking. I'm not sure. If you're asking how do you find the domain and range of the outer in general, the domain and range of the entire function can be ascertained by getting the domain of the inner and the range of the outer. So you think about what's going in at the very start and what's going in at the going out at the very end. So whatever's going in at the very start will be the domain of the g of f of x, the big function, and what's going out at the end will be the range of the whole big function. I hope that makes sense. What happens when a probability distribution function has two functions? Like one part of the composite function isn't zero, how would we calculate the mean, standard deviation, etc.? This is a really good question. So we need to split it up and do each of the sections separately and then add them together. So if you wanted to calculate the mean, you would get the mean from, so I'll just do an example. So say you had a graph that looks like that and like that, two different functions. You get the mean from here to here and the mean from here to here. And you do, so 0 to A and B, 0 to A of x f of x dx plus A to B x f of x dx. Like that. And then you do the same for e of x squared, and that you can use that to get the standard deviation and the variance. Cool. How do we stop doing silly mistakes? This, if I knew the answer to this, I would be a millionaire, I think. But the way that I helped myself with silly, I used to get very frustrated at myself for doing silly mistakes. The way that you kind of get better at it is to do lots of practice and be really kind of be mindful while you're doing the question. You might think, oh, what is the examiner trying to ask? What are the common ways the examiner tries to trick us? Because the examiners are really mean. And the silly mistakes are usually what happens when the examiner has tricked us. So if the examiner tricks you once in a practice exam, write it down, put it in your summary book, and you'll be able to see that every time you do those similar types of questions, and you won't let the examiner trick you again. And also write down all the common mistakes that you do. So for example, if you forget to multiply two negatives to give a positive, you can write that at the end of your summary book or your bound reference. Yeah, so practice is the main thing, and then learning from your practice. How should we approach both exams? I think, as I've said, I think the best way is to figure out what best works for you. And that would be trial and error of different techniques. So whether you do multi-choice first, you do extended response first, trial and error while you're doing practice exams, and you do it to time as well. How and when to use complementary of sine and cos. So you can use the complementary of sine and cos when it is adding pi on 2 or minusing pi on 2. And that's when you just switch them to sine and cos. I think that's what you mean by that. Yeah. But definitely look through the textbook for that, because it can get complicated. I won't be able to explain it right now. It's possible to make the graph exist by finding the largest domain that contains the range. How would this be found? For example, how do we define that? How would we find the maximal domain of ln u? So I would graph that inside function, and I would also determine what the domain of the outside function is. And then you know that the range of the inside has to be a subset of the domain of the outside. So once we graph x squared plus x, we need to restrict the domain of x squared plus x so that the range is just greater than 0. All right, I think that'll be our last question. And we'll have 2 minutes now to go through our survey. Here it is. So please tell us what you think so we can improve these revision sessions for next time. So have 2 minutes to go through that, and then we'll say goodbye.